Okay, so what do you see here? This is we have two switches, S1 and S2, and connected with the connections with a cable. So let's see. I have a situation now. So let's say I have many connections. I have too many devices connected. Okay. I have many devices connected to S1 and S2. So and this all the connections, the speed are set now, all are 1G. Let's say all are 1G, and then included this between the switches. The connection between the switches is also 1G. So when I have more and more devices connect to the switch, so I found that there's a congestion on the ports, or congestion on the ports, because I have too many traffic coming in. There's a congestion on the port, and also on this side. Okay. I also worry that because I have too many devices connected to the switch, and between these two switches, I only have one connections. What if one day this link is down? If this link is down, means that all the traffic from S1 and S2 will be isolated.
Mimikatz, they one of their servers.
So do you have any solutions for this?
Huh?
Do you have any solution for this? Because there's too many devices connected. Here, this port, on this port, the traffic flow through this port is congested. Too many traffic. And then there's only one connection here. If this link is down, my S1 and S2 will be isolated.
Yeah.
So do you have any suggestions I can solve this issue? Solve this
You can release the traffic by trunking.
Okay, I can.
Release the traffic by trunking the ports. The connection between S1 and S2.
By trunking the port, what do you mean?
You said there are too many congestion on S1 and S2, right?
Yes. Okay, and just connect one more port.
Right.
Correct. Okay.
Yeah.
We don't talk about the technology, the trunk technology. I don't care about that yet.
Okay.
Because simply, can I do like this? Just connect one more connections. So what happens if I connect one more these connections? Is it doable? Yes, it's physically doable. Just take a cable and connect on both sides on the ports. So what will happen actually if you connect two? Anything will happen? Can you really get say double the speed? Let's say this is 1G, this 1G, and then this 1G plus total 2G.
So you increase the bandwidth, right?
Are you sure?
Yes. I thought you're aggregating the two, right?
No, we don't aggregate yet.
Okay.
Can I do like this? I just simply take a cable connection and connect both sides. Then I get more bandwidth. Can or not?
Oh, of course.
Are you sure?
Yeah. You can have multiple connections within them, right? S1 and S2.
What about the SDP?
There are different interfaces.
Well, what have you learned from the SDP? Anything? What you have learned from the SDP, now you have redundant. You will cause loops, isn't that? Isn't that this will cause loop? Maybe you have your designated port here, your designated port here, and then your root port here, and then this your alternate port.
Alternate port, yeah.
Yes.
Yeah.
Yeah. So you cannot just simply take a connection as a connect both switch. Yes, then I get a bandwidth. Yes, maybe yes, it do solve the issue of the single point failure. Yes, maybe this link down. Okay, this link will be up. Okay, can, but it doesn't solve the issue of bandwidth. I need more bandwidth between these two switch. So STP cannot solve this. So because this is the STP, the nature behavior of the STP, how it works, actually how STP works. So can I overcome the STP? Can I ask or STP not to block my port and let the traffic to go through on these two connections? Can or not? Yes, we can. So that's why we had to apply another technology. So I have to apply another technology to bind these ports. Let's say on S1 side, only, S1 side, these two ports. I can bind these two ports together into one port. Is it physically one port? No. Physically, it's still two ports. But I want to bind it, become logically one port, virtually one port. And then the STP will no more see these two ports as two ports. You only see the one port, one logical port, one virtual port. So STP will not block one of the port because of the redundant link. So I can have two links. I also can have three links. I can have 4, 5, 6 until 8. So why 8? Actually, this is depend on the product versions. So this had to refer to the headex or refer to the product or the documentation. So whether it's 8 or more, that depends. But when we apply this, usually, because we have to, if we have just one connection, we will not want to apply the technology, this link aggregation technology. No, we have at least two connections between two switch. That's all, so that we can we want to configure the technology. So if this is 3 link, so let's say I can get 3 gig, 1 gig, 2 gig, 3 gig, total 3 gig. Okay, so 3 gig connections. So when there's more traffic like here coming in, coming through, so less congestions because I have more bandwidth between the two switch. And also I have more reliability. So I 1 link down, I still have 2 link going on. I 2 link down, I still have 1 link. So this is the advantage if we can apply the link aggregation technology. Okay, so and then what about routers? So for routers, again, so between two switches, this is in one broadcast domain. But what about for routers? 1 broadcast domain, 2 broadcast domain. Okay, can I combine, use a link aggregation technology to bind these two connections or these two ports together into one logical port? Logical port. Can or not?
Yep, never came across that.
Yes, it can. So this and this, because this if you don't configure anything, these two are two broadcast domain, two different IP. You cannot bind, you cannot aggregate two broadcast domain together. It will become very weird. It won't work. So if you want to do the link aggregation, means that we combine these two ports together, then the connections and the connections for the broadcast domain, there's only one, become only one connection. So become logically one connections. So one connection, connect. So we also, then you can configure the IP address on the logical port.
Right.
This also can use to increase the bandwidth between two routers. Okay. So this is the technology we call the link aggregations. So forward here, so as a means of optimizing the throughput of data, link aggregation enables the binding of multiple physical interfaces into single logical pipe. This effectively introduced solution for providing higher utilization of available links, as well as extended resilience in the event that failure of individual links were to occur. Okay, so engineers are required to have a clear understanding of the condition that defines the behavior of link aggregation and the skill and knowledge for these applications. Okay, so on this section, I will explain where do we apply, what is the scenario where we apply the link aggregation. So mostly it's the enterprise network. Okay, and then I will describe the various forms of link aggregations supported. And then we will configure the link aggregations, the configurations in the ENSP. But this one, yes, we can do this. Later, we also use, because we do use the same topology with the VLAN. Okay, so link aggregation. So link aggregation provides for increased bandwidth and enhanced reliability and support of load balancing. So increased bandwidth, 1 gig, 1 gig, 1 gig, combined 3 gig. So enhanced reliability, 1 link down, I still can go. 2 link down, I still can go. And then support load balancing, if I have 3 links out at the same time. So my traffic will be divided into three paths, three paths. So the traffic can be divided, can be load balanced. Okay, so where do we apply this in the enterprise network? Mostly at the critical point. Critical point means between your distribution switches and between the core switch. Okay, between here. Mostly is here. So actually, except beside from here, we also do it at here. Let me show you again. Oops. This one. Okay. Mostly we also can do it here. So your core switch. So this is your core switch, yeah? And then this is your access switch or maybe access switch. So your access switch always have two links. Go to connections, connect to your core switch. Maybe we don't have this, okay? But we also always we prepare 2 links connect to the core switch for the access switch. So that because we have too many devices here, so I can put 2 links. So to increase the bandwidth and also to increase the reliability. Because 1 link down, I still can have 1 link going on. It's up. And then I can use the time. I can still have the time to fix this error. Okay. Okay, so for modes, link aggregation modes.
Start the weekend and not I did not day around, so I'm not on to the when I come back in Nago, leave in Nago, sit down, you see, they tell you me pay money, Abi? So you see me, they pay money.
Okay, so link aggregation mode, we have two modes. The first mode is what I'm explained until now and described until now. So manual modes. Manual mode is very straightforward. So how you have a logical link, and then that depends how many ports you want to assign into the logical ports. So depend on how many you assign, then you will get how many bandwidth. So I have 3 connections, 3 ports. So I have the some, maybe I have 1 port is 1G, so a total 3G, and then this is always up. 3 on all 3 ports. It's always up. In manual, it's very straightforward, very simple. So this is also the first concept we have, the first modes in the industry, first modes. So later, because we have some issue at here. So let's say the manual mode. What happened? What are the issue at here is, so when there's nothing happen, I have 3G. Okay, my speed is 3G. So let's say one link is down. What is the speed I get? If the network is stable, I have 3G, 3 gigabit.
Yeah.
If one link is down, what the speed become? 2G. So what happened? Suddenly from 2G drop to 2G. What happened? Your bandwidth, like you are on a highway, you're on the roads. You have 3 lanes. Everyone go very fast, 3 lanes. And then suddenly, one of the lane is disappeared. Only left 2 lanes. What happened? What happened at there? So sudden, become 2 lanes. So there might be accidents happen. So there might be congestion happen. Everyone suddenly need to stop down, or your car needs to slow down. Everyone slow down. So by slow down means there's a congestion. So in network, when there's a congestion, what the switch will do is they will start to drop the frame. It means drop your data. So in enterprise network, this might be not so, because in enterprise, maybe your data is dropped. You can just reset again. Okay, but for some scenario data center, or maybe you are uploading some important files, very important files, data, so you cannot afford to drop packet, drop frame. So instead of this, can we have another technology? Let's say LACP modes. What is LACP mode? Here is we can configure. Even though we put 3 ports, we assign 3 ports into the logical ports, but we can configure some backup. Some ports are active, some ports are backup. Here, LACP mode, I can configure 2 active, 1 backup. 2 active, 1 backup. So what the speed I get is 2G. 2G. So that means when there's a link down. So what happened? So what happened? The backup port, or I should mean the backup link, not the STP backup port. Okay, the backup path will become active. So I still get 2G. 2G, 1 link down. Then the backup part, 1 link is up. So total, I still have 2G. So no congestion, no suddenly drop in the bandwidth. So no drop of no frame dropping in here. So this is better. And also here and another scenario is this. So what happens is like this. On this switch, I assign this 4 port into one logically. This 3 port into one logically. This I don't assign anything. And the switch knows that this 4 port, the other side of these 4 ports is actually connected to 2 different switch. Can or not? In manual mode, cannot. They cannot do validations. They cannot check. Okay, port 1, 2, 3, 4. Is at the other side is connected to the same switch or not? I don't know. I just know that the administrator configure. Okay, this 4 port is combined to one logical link. I just use these 4 ports to do the load balancing. Means that somehow the packet, the frame, I want to send to this switch. Maybe I will send to 1, 2, 3, 4. I mean this frame will go to kind of this switch. So maybe this frame go to the wrong place and it will be dropped. So we don't want this. This is some of the cons. Some also, I should say, some weakness of manual mode. So still we can apply this LACP modes. LACP mode can check because LACP mode they can send a LACPDU, link aggregation control protocol data unit. Means that both switch they can send a PDU to each other to check, to validate. Is these 3 ports connect to you, and you should reply me on these 3 ports. So it means that maybe this switch send 3, 1, 2, 3 LCPDU with his own MAC address. Because one switch only have one MAC address. Okay, so this switch will reply in all the 3 connections with his own MAC address inside the frame. So this switch will check on these 3, receive these 3 reply from the same MAC address, means same path. So then I can know that since I already confirm that all these 3 ports is connected to the same switch on the other side. So I will up the port. I will active up the logical port and logical link is up. So if the switch detected one of the ports is actually connected to another switch, maybe the other switch is not configured with anything, so it doesn't reply. So the switch will very intelligent. You shut down the port, put the link down, put the ether trunk to down. So this is what we do. So LCP mode. So from here, up to now, so what you can conclude is if your switch can support LACP mode, you use LACP mode. Means the ether trunk or the ether channel in the ether trunk is Huawei. Ether channel is Cisco. So if your switch can support LACP mode, please do use the LACP mode. If your switch maybe it's a very legacy switch, it doesn't support LACP mode, so maybe you have to use the manual modes. If you are using manual mode, please make sure both sides of the switch means that the other side, the other end of the switch is really connected to the same switch. Okay, so so again, so LACP mode also can support active backup. I can have 2 active, 1 backup, or 1 active, 2 backup, or maybe put more link together. Also can. So, but you also can have all 3 active also can, especially in situation like this. You have only 2 connections. I get 2 connections, so I would prefer I put all 2 are active. So flow control 2 switch. I have already assigned into the set 3 ports into 1 ether trunk. So what are the criteria for this to work is both sides duplex mode full. If one full, the other side also full. If one end is half, the other side also half. But of course, nowadays we prefer full, and then we do not prefer half at all. Okay. And then the speed on the both sides must be the same. Here is 1000 meg. Here also must 1000 meg. Okay. And then so also the consistency of physical member interface must be maintained. Means these are 3 ports. They also have 3 ports. Okay. Number of ports. So next, this is layer 2 link aggregation configurations. So this does very easy. You configure the interface. You create the interface. Interface is a trunk 1 created, and then you assign the ports. You can go to that physical port and then put ether trunk 1 for this one. This is the number ether trunk interface number. Or you can see the interface ID. Ether trunk means if you put here on the physical interface, you put ether trunk 1 means you want to assign this into ether trunk 1. In the E2, G2 way. So you put this command means you want to assign this into ether trunk 1. So you see this. This is layer 2, and then this is layer 3. So you can create the interface ether trunk. So by default, an ether trunk interface is a switch port. It's a switch port. It's a port that you cannot configure IP address. So it's a switch port. So you can use the undo port switch. Undo port switch, so it can become the layer 3 ports. Ether trunk change the ether trunk become layer 3 ports. Then only you can configure physical IP address onto the ports, the ether trunk 1. Then you can click, and then only you assign these 2 ports into ether trunk 1. Okay. So and then when there is a member ports inside the trunk, you cannot change between the manual mode and the LCP modes. If you want to change the mode, you must remove all the port members, move away all the port members. Then only you can change the mode. So to display, you can use display IP or display interface ether trunk 0, ether trunk 1. Then you can see the trunk 1 currently up, and these are the port name and their status, and this the weight. So number of port, how many? Up port, how many? So if an administrator attempts to add a gigabit Ethernet and fast Ethernet interface to the same ether trunk interface, what will occur? 2 different speeds you want to add into the same ether trunk interface. What will happen? Can it work? Or I should say, can it works?
No.
So according to this syllabus, it cannot work in this IAINS. So it cannot work because there are 2 different speeds on 2 ports. But this also depends on the product versions. So for older product model, product version, it might not support this. But for new product version, yes, it can support this. Maybe you have one fiber port, optical port. One is support 10G, And then you have another port. It's a electric port, UTP. So 10G, 1G, you can combine together, become 11G. This is, you only can use this in the the new product version. So what I mean also is you have to check the product documentations to see which one are the models that support this kind of configurations, multi bandwidth in the Ethertron. So in order to establish backup member links, which mode of link aggregation should be used?
LACP.
LACP, correct. Oh, wait, no more please. Open your or maximize your ENSP. Okay, so since you already started the device, so what I'm going to do now is I have S1, S2, and S3. So I want you to configure the Ethertron to combine this tooling and this tooling, and then bind together this tooling, this tooling. Okay, so then we can apply link aggregation on these two connections. So the commands is already prepared on below. So for S2, you guys have to configure the host name, create the trunk interface, Ethertron1, and then mode. Please choose LACP. This by default is manual mode. Manual mode. I want you to choose this. Then this is a very a bit faster way to configure to assign the port into the trunk. It does inside the LACP static modes. You put trunk port G1 and then trunk port G2. This on this side, S2 only. So for S1 is more. Okay, S1. Sysname, the interface and the logical interface number is the trunk 1, and then change the mode. Then assign the port into the trunk. Okay, G1, G2, and then you also can create another logical port for another site, another connections. So also can put both LACP trunk ports. Of course, last one on the PC4, no, the S3, So change the host name, create the trunk interface, then change the mode, and then assign G3 and G4 into the trunk ports.
So, Mr. Bay.
Yeah, this G3 and G4.
Hello?
Yes.
So another way of saying the trunk port is it the same as saying go to the interface and then assign a trunk 1?
Also can Ethertron and your number, Ethertron interface number. That's Ethertron 1, Ethertron 2, 3, or 4, 5. So that depends on what you configure at here.
Okay.
Declare at the system view. So do this. So please do this.
Yeah.
This kind 1, 2, and 3. So after you finish your configurations, so always can check. So for S1, you can check display. Okay, you can just interface brief. Okay, and you can check. The trunk Y is G1 and G2, correct. The trunk 3, G3 and G4. S2, display interface brief. See, okay, G1 and G2 is in the trunk 1. And then S3, display interface brief. And then C3 and 4 is in interface trunk 3. 3 and 4. Okay. Okay, and another command, display interface trunk. From S1 interface trunk 1. So from here, it is display interface trunk 1. You can see the both is still up. Okay, both state data trunk 1 interface and the line interface up. And then switch port, the VNID is 1 as default as usual. So maximum bandwidth. Okay, maximum bandwidth 2G, current bandwidth 2G. Okay, this is what we want. And the maximum is that. Okay, so frame length, and then this is the MAC address. Okay, then how many ports in this ether trunk? So I have 2 ports is still up. So after that, when we also you can open the S1. Let's check display SDP brief. Display SDP brief. Now you see, even though we have 5 connections on the switch, so but switch you see the 2 connections is either trunk 1 and the other 2 is trunk 3. Okay. Of course, go to S2, display interface. Okay, with the trunk. Let's say this is using 1. Okay, right now the status now is down. So display interface is the trunk. Okay. Okay. So both the port is down. What happened actually here? Alright, it's okay. So can you get this until here? Can you follow? Okay. So Dr. Bala, can you get to here? Okay. Anyone cannot? Anyone cannot follow? Okay, since everyone can follow, means that this is all what we need. The configurations we have already learned, and then that's all. Okay, or we can try one more configurations. Okay, let's say inside the ether trunk interface, ether trunk. Let's say this as one, and I put the next. Okay, next actively member. Oops. Max. No. Still trunk one. Oops. Where is it? No. Max. Okay. With R2. No, S2. Max. Oh, I see. So maybe you should go to your S2 and then put the command max actively member 1 to 8. I just put 1. I just put 1. Then display interface is the trunk 1. I can see. Okay, both is down. Why? Both is down. Shouldn't be. This do shutdown. Oh, it's still down. Maybe there's no connection here or something happened. But there's okay, or maybe I just try to ping.
So, Mr. B,
Yes.
for some reason on S2, I can only see 1 gigabit interface. 01.
Because you didn't put the trunk ports. You didn't assign the trunk port. You didn't use the trunk port command to assign the port into the ether trunk 1.
Ether trunk 1 is up, but I can't see the second one.
Then S2, you mean in S2?
You're in S2, yeah.
In S2. So, or you just use it display interface brief. Display interface brief.
Okay.
Okay.
Yeah.
So what did you see ether trunk 1?
1 and 2 is up, 5 and 6 is up.
5 and 6, I mean S2. S1, S2.
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 Yeah. S2.
S2.
Yeah. 1 is up, 2 is up, 5 is up, 6 is up.
S2. Oh, see. 5, 6 are up. Do you see the ether trunk 1?
Ether trunk 1, yeah, it's up.
So below here, G1 and G2 is up, but the ether trunk
yeah,
1
my
is down.
ether trunk is up, both cases.
Okay. Okay, then that works fine. See, let me sort the command. Okay.
Maybe you can clear the settings and.
Yeah, I forgot to change the mode. So I can go to the ports to change it. 1 and do ether trunk. Phase 002 and do ether trunk. Oops. Okay.
Yeah.
And
Win cap.
okay. So I go to S2, again display interface brief. My Trunk 1 is up. Go to S1, display interface brief. Up is all is up. Finish. I still cannot. Maybe I don't put this. Oh, sure. Next. Okay. So can you try the ping? PC1 ping PC3.
PC1 to PC.
PC1 ping to PC3.
Okay.
And PC2 ping PC4.
Ping. What's the IP on? What's the IP on PC3?
You can double click on the PC3 and check. Open PC3, check. Is 10.0.0.2.
Okay, okay. Basic configuration is static here. Then to PC3, right? PC1 to 3.
Yes.
Okay. Yeah, it's live.
It's live, huh? Why mine can't? Okay. So mine T002.
S2 and S3 both allowed the access to be on default LAN in default VLAN 10. They should go through.
We don't configure any VLAN yet. They should be all in same broadcast domain.
Well, we copy the configuration you sent.
You mean below here?
Yeah, it's what we used.
Oh, you configure already.
Yeah, it's configured already.
Okay. So that, no, I haven't configured yet, because we just want to learn the Ethertron only for this topic. But you configure, then never mind. You just leave it. You just you have configured it. So okay, we can pin now. So because I don't configure any VLAN, so this everyone is still in the same broadcast domain. Okay, one broadcast domain. I don't configure any VLAN yet. So it's just logically one port logically. Okay. So this is Ethertron. Okay. So okay, minimize your ENSP. So now we're going to the another topic. Okay. Okay, let me open my ENSP first. You can just minimize yours. So just look at mine. So now, your PC1 IP address is 10.0.0.1. Okay, and then your gateway is 10.0.0.254. But it doesn't matter. I just want to tell you what you need to know is the subnet mask is also 255.255.255, which is 24. Makes the network address of PC1 is 10.0.0.1, 10.0.0.0. And then, but for PC2, what's the IP address for PC2? It's 10 is someone 20, 20.0.0.1. Subnet mask 255.255.255.0, which means 24. And then gateway 20.0.0.254. So this the network address of the PC2 is 20.0.0.0. Okay, two PC with two different network address. I connect them to the same switch. What happened? The same switch. I don't configure any VLAN. So in the point of view of these three switches, they are in the same broadcast domain. So for PC1, what PC1 do? Okay, let's see. I go to check G6. From S2, I capture the traffic on G6 to PC2. Okay, I go to PC1. I put ARP -A to check. Okay, inside my ARP cache table is empty. Okay, means that now I want to use my PC1 to ping PC3. Yeah, PC1 to ping PC3. Since PC1 doesn't know what is the MAC address of PC3, because PC1 and PC3 is in the same network. Okay, using the same network address. Okay, so PC1 will send the ARP broadcast, ARP request, which is a broadcast frame to look for PC3. So this is my Wireshark capture. So let me filter out the STP traffic. I put not space STP, enter. So I filter out the SCP BPDU. So now PC1, I ping PC3. Oops, cannot work again. So PC, or I just use the PC3 to ping back the PC1. So whatever. So what do I get here? See, who is this? So the PC3, you see the PC3 MAC address is end with 6BC7, 6BC7 here. So this is ARP broadcast. Looking for 10001 PC1 and tell 10002 this is PC3. And this broadcast, what happened? You go out from PC3, the ARP request, go to S3, S3 broadcast. Okay, so S1 also broadcast. Right here, broadcast. So S2, what S2 do? Broadcast. Yeah. Okay, broadcast. This is what you see from here. I capture the ports. I capture this port, and the broadcast pass through to PC2. The ARP request coming out from PC3, go to PC2. So even though we use the IP address to separate, okay, we put the network address. It's like this. This is one network. So PC2 and PC4 is another network. Or I should choose this, another network. So, but in point of view of the switch, the layer 2 switch, it doesn't know. I just look at the source and destination MAC address, because the source and destination MAC address doesn't tell whether this packet is from which broadcast domain. No, okay, or from which which network? I mean, which sub network? So what I can do? This is just the 4 devices. If I have more devices, all the devices may use a different network address. So when they try to look for someone in the same network, they send out ARP request. But this ARP request will broadcast to another PC. Okay. So what we can do? Can we separate? Because PC1, PC2 using the different network address. So, but we are connecting them to one switch. So, can I? This is not a good practice. Okay. So we can separate them. How we can separate the broadcast domain? So remember what we learned last week. How to separate the broadcast domain? We use a switch to separate the collision domain. And then we use the router to separate the broadcast domain. Because for a router, 2 ports, 2 different ports is 2 different broadcast domain, 2 different network. So we can use a router to connect PC1 and PC2. Okay. So this is how you can do it. But if I have so many devices, so many networks need to separate, it will be very troublesome. Too many devices need to invest. It will increase the cost. So that's why we introduce another layer 2 technology, what we call the VLAN. This is another technology. Okay, VLAN, Virtual Local Area Network. So it represents a form of administrative network that define the logical grouping of hosts or end system device. Okay, they are not limited to physical locations. Okay, what do we mean? So I'll explain the application of VLAN tagging and then describe the different port link types and their own characteristics. We have 3 different ports. We have access port, trunk port, and the hybrid ports. And they have their own, each of them have their own characteristic. And you must understand. Also, you must understand the characteristic of each of the ports. And then we will configure the VLAN in the ENSP. So LAN limitations, one local area network, no broadcast domain to manage expanding local networks. This is what I have shown you just now. You send one broadcast frame, you go to everyone. Okay. So this is one PC sending. What about this PC also send? This PC, this. You see some kind of broadcast stop here. If there's too many ARP requests and too many broadcast frame, so can we separate them? Yes. Okay, logically separate them by using VLAN. So VLAN enables logical isolation of traffic at data link layer. You see, if we are using a router, I separate the traffic at what layer? At layer 3. Layer 3. So, but if you're using VLAN, VLAN is a layer 2 technology. So we can use a VLAN to separate traffic at data link layer. So not limited by physical locations. What do you mean by this? See this PC. This PC is connected to this switch. This PC connected to this switch. Connected to two different switch. Two different switch also can be a same VLAN, same broadcast domain. Or I connect to the same switch. Two PC connect to the same switch, but you also can be a different VLAN, different broadcast domain also can. So this is the advantage, the strength of using a VLAN. And doesn't limited by the physical locations. So how VLAN works? Okay, so how VLAN works? So I'm open this, so you can see this. This is a frame. This is a normal frame you see. Okay. See, PC2, PC2, those are ping here, ping 20.0.0.2. So ping request, this is a normal IP packet or normal frame. We see your Ethernet 2, and then IPv4, then your ICMP. This normal frame. But this is what we call untagged frame. Untagged frame means there's no VLAN tag. So how the VLAN works is, because they add a tag into your frame, then it becomes a tag frame. So this is important. Okay, so this tag is added after your destination and source MAC address, and then the tag and then the type. But let me open a website to show you something else. No, it's already, I already made the slides. Yeah, exactly the same thing. So this is what we copy from the Wikipedia. So we have the destination MAC address, source MAC address, and then this is the tag. Is the standard for this is 802.1q. Remember the term 802.1q, and then you see the type. And then this is the data, and then your frame track sequence FCS. Okay, so this is the tag. The size is 4 octets. 4 octet means 4 bytes. 4 bytes. So here in this tag, okay, what we have in this tag? The first one, TPID. Okay, the tag. So 8100 means 802.1q. What is this? This is to tell all the switch, all the switch receive this tag frame. They will check. Okay, this is the destination MAC. This is the source MAC address, and then there's a tag. What is this? So they read the first 2 bytes. First read the information. Oh, 8100. Okay. Then the switch node. This is the VLAN tag. VLAN tag, and then they check the VLAN ID. 12-bit behind here. TCP and DI is used for the QoS, quality of service. It is not so important, but most important in this VLAN ID. So this will show which VLAN does this tag frame belongs. Okay, VLAN. So VLAN ID 12 bits. So 12 bits means 12 bits. How many number you can show with 12 bit? 12 bit. Now is 2 power 12 equal to 4096. But for VLAN, 0 and 4095 means you can have 0 until 4095. Okay, the number. But 0 and 4095 is reserved, so you can have VLAN 1 until VLAN 4094. So by default, VLAN 1 is already created. You cannot delete, you cannot destroy this VLAN 1. And all the ports are in VLAN 1 by default. And all Huawei ports, switch ports, are in hybrid ports, VLAN 1 hybrid port by default. Okay, and then you can create the VLAN 2 until 4094. And also you also can destroy the VLAN 2 until 4094. But not VLAN 1.
Are we doing logistics this month?
Okay. Sorry again. Which wow. Sorry, what's your questions?
Villa. Oh, sir.
Okay. Okay. I continue first. You take your time. Okay. So what is important in this? So depend on what is the numbers showing the VLAN field, is that this is which the tag frame from which VLAN. So the VLAN tag is inserted to distinguish the frame for each VLAN. Next, link types. A trunk represent the backbone for the transmission of VLAN's traffic between switches. So what is in VLAN? We see this the link between switches we call trunk. The link between switch and end device we call access link. Trunk link and access link. Okay. So, and then we have this port VLAN ID. Okay, PVID or port VLAN ID represent the default VLAN for each interface. The PVID is set to VLAN 1 for all ports by default. So each of these ports have VLANs. Okay, what does it mean is PC and devices, they do not understand VLAN. They don't accept tag frame. Only so everything who do the job is actually all the switches do the jobs for your VLAN. The end devices doesn't care. So how you configure the VLAN is configured on the switch, not on the PC. The PC doesn't care at all. So you can configure for each port. It may have their own PVID. All are default to 1. So take an example. Let's see. S1 display port space VLAN. Display port VLAN. You can see. The Ethertron 1, Ethertron 3 in hybrid port 1, PVID 1, VLAN 1, hybrid port VLAN 1. And this 1, 2, 3, 4. Let's see, 1, 2, 3, 4. Yeah, 1, 2, 3, 4 is inside the Ethertron ports. So they are VLAN 0. So you no need to configure this. If you want to configure the VLANs, you configure on the Ethertron. And then for other ports, G5 until the G24 are the hybrid ports, VLAN 1. Okay. So yes. So the first port types we have is access port. Access port is the port we usually use to connect to end devices. So
Okay. Yes, sir.
yes. Yeah, any questions you want to ask? You found it? Okay, continue. So we see the access link. Access link connect to the VLANs. So you can create the access link actually by configure the ports or as an access port. Access port. So access port remove VLAN tags before forwarding the frame. So host again host a PC send an untagged frame because PC doesn't understand VLAN, so you send an untagged frame, a normal VLAN. So when go until the switch receive. Okay, the switch see, okay, I received the untagged frame at port, access port, PVID 10. So what should I do? I tag the frame with a 10, VLAN 10 tag. And then, okay, this VLAN 10 tag frame, now I want to forward out. So where I can forward it out? So only the port that can remove the tag, I can forward it. So I only forward it to the port that can remove the tag. So only the access ports with the same VLAN ID can remove the tag. So here I have this port is PVID2 access port, so this port cannot remove the tag. So I don't send it to this, send out from this port. I cannot send out from this port. And this port, okay, this port is same. Access port PVID10. So this port can untag the VLAN tag. Okay, so I forward this out from this port. This port will we can say untag the frame, untag the VLAN tag, and then send out the frame as an untagged frame, send to host C. Okay, so okay, can you understand this? Understand this concept? So if I have further details on access port. So our ports are hybrid ports. VLAN 1. Okay, this is what I have told you, hybrid port VLAN 1, and also untagged 1 by default. Okay. You see the first example, this one. Okay, untagged frame coming into a access port VLAN 99. So since this is a access port, so you see untagged, then coming in to the switch as a tag frame. Okay, a tag frame. Okay, when there's a VLAN frame, a VLAN 10 tag frame coming into a access port, VLAN 99 access port. So what happened? Cannot come in. Okay, discard. And then we're going to set up, okay? If this is a 99, okay, 99, VLAN 99 tag frame, okay, and this is the access port, VLAN 99 access port. Of course, this port can strip away the VLAN tag, so it will come out, go out as a untagged frame. Good. Okay, but if this is a VLAN 99 tag frame, and then this is the access port 10, VLAN 10 access port, so cannot go out from here. So you must understand this. These are the behavior of an access port. Okay. This also means that access port can untag. Is the VLAN tag, the VLAN tag frame with the same VLAN as his own VLAN, its own PPID. Okay. Is that the hybrid port 1 also can untag VLAN 1 frame. That's why when coming out is become a untag frame. Okay, so this is some some characteristic of an access ports. So next one, trunk port. Trunk port is a port we configure between switch, or we can use a trunk port to create a trunk link between switches. This because we configure the port. Become trunk port. Okay. So why this is a trunk port between switches? Because we want to allow, if we use this as the access port, we only can, let's say, host A send the VLAN 10 tag with untag frame going, become a VLAN 10 tag going out. Okay, if this is the access port, of course, VLAN 10 can go. Okay, but when coming, there's a VLAN tag coming from VLAN 20, but this is a VLAN 10 access port. It cannot go out, cannot. So that's why, because these are just 2 VLAN. Maybe there are more VLAN. So, but we only have one link to the other switch. Maybe we have only one link to our core switch. So we provide options called trunk ports. Trunk ports can allow VLAN tag frame, a tag frame from different VLANs to pass through. So VFrames carry over a trunk link, may be tagged or untagged. It can be when a frame coming out from the trunk ports, it can be an untagged frame, it can be a tag frame, tag or untag. So, but all VLANs must be permitted before being carried over a trunk. Okay, so it means that it doesn't mean that this is a access port 10, so we don't care about this. This is what you already know. So if you are VLAN 10 tag frame, it doesn't mean that if this is a VLAN 10 trunk ports, you'll be allowed to pass by default. No, you have to specially configure to tell the ports allow pass VLAN 10 tag frame. Okay, then only the port can allow the tag frame to go out. But also, this is what's the similarity with the trunk port with the access port is. If the trunk port sees the VLAN 10 tag frame, they're allowed to go out. And the VLAN ID is same as its own, same with its own VLAN ID, it will untag the frame. So it can be out, become an untagged port. Okay, so this one is VLAN 20 and sending out from here. VLAN 20 frame also allow pass, but because different VLAN tag with different VLAN ID, with the frame VLAN ID and the port VLAN ID, the trunk port VLAN ID. So the port trunk port doesn't allow to pass, doesn't do anything. So coming out VLAN 20 tag frame. So when going in, we also need to configure allow to pass. But here, if this is an untagged frame, when going into a PBID 10, what happens is the trunk port also do the same thing with the access port. It will tag the frame with a 10. Tag the frame with 10. Okay, so this is now going in as a VLAN 10 tag frame. So it can only go out from VLAN 10 access port, but not VLAN 20 access port. Going out as an untagged frame. Okay. So I'd like you to see some more information for this for your reference. So you see, there's a switch. So when there's a port, when there's a untagged frame coming into a trunk port, a VLAN 1 trunk port coming in, so the frame can come in, become into a switch. Instead of switch, the frame become a VLAN 1 tag frame. Okay. When same as here, when this is a VLAN 10 trunk port, the frame coming in as a VLAN 10 tag frame. Okay, when going out, S1, so T1 is if inside a configuration, even if you doesn't see the see the allow pass, you don't configure the VLAN, you don't configure in the switch, you doesn't configure the VLAN 1 to allow to pass, allow VLAN 1 to pass, but VLAN 1 tag frame is allowed to pass by default. You don't need to configure. Okay. That's why you can see here. Even though I don't configure allow pass, here can go out because same VLAN ID with the port. So coming out untagged frame. If different VLAN ID, again, VLAN 1 tag frame is allowed pass by default. So it's going out as a same VLAN frame, no change, VLAN 1 tag frame. Okay, if this is a VLAN 10 frame, and then this is a trunk port, VLAN 10 trunk port, and allow pass VLAN 10 also, so it can go out. Okay, this frame can go out from these ports because same VLAN ID with the trunk ports. So it will be the tag will be stripped away. Okay. If this is a VLAN 99 trunk port, like allow VLAN 10 tag frame to pass through. So this is a VLAN 10 tag frame, it pass through as a same, nothing, no change, still a VLAN 10 tag frame. Okay, and then if this is a VLAN tag frame trying to go up on this port, but this port is a tag. VLAN 10 trunk port, VLAN 10 trunk port, but we doesn't configure this allow 10, no allow, means that still not allowed, cannot go out from this port. So these are basic characteristics of a trunk port. So access port and trunk port is the two ports that we very common in the enterprise network. Okay, now we have one more type of port called hybrid ports. Hybrid is a combination of, or I should say, you can use a hybrid port as an access port, or you can use a hybrid port as a trunk port. So this depends on how you do the configurations. So hybrid port are defined as either tag or untag. So hybrid untag or hybrid tag. Hybrid untag means it behaves like access port. The hybrid tag port, it behaves like a trunk port. So it means between switches, you configure hybrid tag port. Between switch and the end device, you configure the hybrid untag ports. So VLAN communication can be managed on ports by port basis. Okay, so you can see from here. So there's a little bit difference for hybrid port with the other two ports. Okay, so still the same. Host A, the PC doesn't understand tag frame, so PC always send the untagged frame. Okay. So going in as into a hybrid untagged port. If I put this is a VLAN 10 hybrid untagged port. It will just functions same as a access port. So when the frame going in, it becomes a VLAN 10. Okay, VLAN 10 tag frame. Okay, when coming to the hybrid tag port need to also have to specially define. Okay, this tag VLAN 10 means the allow paths. Tag means allow paths. VLAN 10. Okay, then VLAN 10 can go through. But this time when it goes through, even though the port VLAN ID is same with the port VLAN ID. So but the frame, the VLAN tag is not removed. It's not removed. Same as for 20 and the frame. Okay, when going in also have to here to configure the same thing, hybrid tag ports. Okay, and then allow to tag VLAN 10 and tag VLAN 20 to allow past the VLAN 10 and 20 to go into the switch. So this 10 and 20, of course, 10 can be the tag on the VLAN 10 frame can be stripped by the VLAN 10 hybrid untagged ports. Hybrid untagged port. And also VLAN 20 can be 20 VLAN 20 frame can strip away by the VLAN 20 hybrid untagged port. But this is a special case or the advantage, the strength of a hybrid port. Hybrid port also can untag. The hybrid untagged port can also untag the VLAN tag frame from other ports. Let's say this is VLAN 10 tag frame. It can go out from a VLAN 20 hybrid untagged port because it's just a way to configure to tell the ports. Okay, you not only have to untag your own VLAN frame, VLAN 20, you also have to untag VLAN 10 tag frame. So what is the difference between the hybrid port and the trunk and access port? So between hybrid port and the trunk port, the difference is here. Even though same PVID with the frame, it doesn't remove that. Okay, and then between hybrid and the access port is access port only can untag one VLAN. Okay, but hybrid port can untag server more than one VLAN. Okay. So let's going on with some of the examples of a hybrid ports. Okay, so you can see from here, if there is untag, okay, untag frame. So coming in, you have to special configure. Even though this is okay, this is hybrid ports of not VLAN 99, VLAN 99 hybrid ports, and you have to tell the port to untag yourself. Means that this is a complete access port. Complete like access port can be works like access port. When going in is a because it's the PVI VLAN 99, so VLAN 99 tag frame. Okay, next one. If you just configure the hybrid port, configure it become VLAN 99 hybrid ports, but you don't configure the untag. So even though it's empty, cannot access, cannot come in. And then you just configure the hybrid port and VLAN 99 hybrid ports. You don't configure the untag, but instead you configure the tag 10. Means you allow pass 10. VLAN 10 tag frame. So with a VLAN 10 tag frame coming in, yes, it can go in as a VLAN 10 tag frame. Okay, on the other side, when there's a 99, VLAN 99 tag frame going out. This is a hybrid port 99, VLAN 99 which can you tell you to untag 99, so you can go out as a untag frame. So see a difference between this and this. This is a 99 VLAN 99 tag frame. When going out, this is a hybrid port VLAN 99, but this time is a tag 99. So it will send out as a tag frame. This untag 99, you tell the port to untag VLAN 99 tag. This you just tell the tag it. 99 go out as the same frame, same thing. And of course, this and this, the same thing. You are 99, even though this is a hybrid port VLAN 99. Sorry, I don't know if you want either untag or tag. If no, nothing means no, cannot pass. Discard, or just cannot coming out from this port. Maybe you can go out for other suitable ports. So next one, if this is the VLAN 10 tag frame, of course the same thing. If this is the hybrid port 99, even though different VLAN, but you tell the port to untag the VLAN 10 tag frame also. You also can untag the frame and send out. Also, even though this is a hybrid port, VLAN 99 hybrid port, if you tell me to untag, or tell me to tag VLAN 10, so VLAN 10 frame going out also a tag 10 allow pass. Is still a VLAN 10 tag frame. So from here, this is again about VLAN 1. S1. There's a VLAN 1 tag frame going out. So this is a hybrid port VLAN 99. You put a tag 1. Tag 1 means allow pass 1. So you will see 1. So but here, I said VLAN 1 is VLAN 1 tag frame. This is one frame. VLAN 1 tag frame is untagged by default. Means that by default, S1 there's a VLAN 1 tag frame going up. Whether it's a port for other VLAN 99, VLAN 99 hybrid port doesn't care. VLAN 1 is tag frame is untagged by default. It still go as a untag frame. So this is the default configurations. If you want the frame to go out, VLAN 1 tag frame to go out as a normal VLAN 1 tag frame, you just have to configure the tag 1. So until here is the hybrid ports. Hybrid. So it's 5:53. Let's take a 15 minutes break before we continue with the slide behind. So you try to digest access port, trunk port, and hybrid ports. E11.
Okay, no, sir, no problem, sir. Hello, sir. Yes, sir. Okay, sir. Hello, sir. Hello, sir. I can't clearly hear you, sir. I don't know if I can call you back, sir.
I got the
Who sent it, sir? Who sent it, sir? You are saying something that's in my voice. I'll get back to you. I'll get back to you. Please. Sir, you know, let me do it, sir.
Now for increasing employees, new employees. They have new employees. I think we employed some people.
Even when we do officer, I don't know if the person is getting usually. But it's possible because you don't that and I'm such a because you say it's actually but you understand. Like this stop there's not like this thing. It's supposed to stay the same story. And that's why you won't see the attached document.
Hello, doctor. Ka yi kokari tun da ba mu san kiɗin dama hannun waye ba ne, ka yi kokari sai ka zo in case sun an samu wanda kiɗin kenan suna jira nan contractor ne sai ka zo sai ku yi da su da Allah saboda dole za su nemi wanda zai za su yi aikin tun da kana yi. Yawa, yawa shi ke.
It's not showing and I logged in. So okay, no. I feel this. I feel this. It's very unsafe. I'm going to check the rule.
Okay. Okay, by close of work today, we can isolate it. Okay, till him upgrade it. You know the perfect. Okay, which okay. Then this sub server. I mean, so yes, I think it's that. We couldn't have internet access on that. So I want to check when things. Okay. And so I was actually touched everywhere that. And then I have some IPs of your block from the firewall. It's my address. I will do that. It's going to be in my mail, I need to observe Ismail do that because he often calls someone. Yeah, that's
Okay, so let's continue. So I would like to add on some more on the access ports. So this is one I added on. This is about this. So when there's a VLAN 99 frame coming in to a VLAN 99 access port, okay, what will happen? It's just allowed to come in. Okay, just allowed to go into the switch. Okay, when going out, look at this and this for going out. And then another one for router for the trunk ports. This one. Okay, this one. So when this is a 10, VLAN 10 type frame. So even though this is a VLAN 10 trunk port, if it doesn't configure to allow 10, it cannot come in. Cannot. So this one and this one is same thing. Same. Just one is going into the switch, another one is going out, coming out from the switch. Okay. So access, trunk, and hybrid. So next, VLAN assignment methods. What are the how you configure the VLAN on the switch? So 5 types. There are 5 methods of VLAN assignment methods. So port-based VLAN assignment method is the default, the most default and the most commonly used nowadays, today. So what is port-based? This is a port-based means that no matter your end devices, no matter what your end devices is, as long as it connect to port G1 and G3, example here is G1 and G3, always is in VLAN 5. If your end device is connected to port G2 or G9, it always is inside the VLAN 10. This is port based. So second one, MAC based, based on the MAC address. So the switch will look at the MAC address of your end devices. When your end devices MAC address is, let's say AA or CC, it will be assigned, or the switch will look at the source MAC address of the frame and say, oh, this is this MAC address. This frame is source MAC address is AA, so I put a VLAN 5 tag into the frame. Okay, means that if you are AA or CC, you are inside VLAN 5. Then if you are BB or DB, you are inside VLAN 10. So this is MAC based. This is useful when the host is always changing its location, but you want the host always only inside the VLAN 5 or VLAN 10. You can use MAC based. Another one, third one is a IP subnet based. This depends on the IP address, the network address. I should say network address of the end devices. If the network address of the end devices is 10.0.1, okay, the frame will be assigned with a tag with a VLAN 5. If is the IP address, if the source IP address is 10.0.2, will be assigned with VLAN 10. Then protocol base. Yes. Yes.
I thought the IP can only be on a layer 3 switch, is it?
Okay. On a layer 3 switch. So this is a special case. Okay. So this is just look at the IP address. Okay. But in the live production, we usually just use the port base is the most common one, and
yes,
sometimes you can apply MAC base also. IP subnet protocol and policy base, not much people is using in the enterprise. Yeah, this means if this is IP subnet base, means the switch knows how to read IP header. Okay, knows how to read the IP header. So you can say that the switch is a layer 3 switch. Yes, you can say like that. Of course, either you are layer 2 switch or layer 3 switch, both can do VLAN. Port-based VLAN, MAC-based VLAN they can do. You can just use a layer 3 switch, just like a layer 2 switch. Can also. Doesn't matter. Okay. And then Okay, then the fourth one, protocol base. If you see the IP header, doesn't care what is the network address. If you see an IP header, assign to VLAN 5. If you see IPX header, assign to VLAN 10. But nowadays, no one use IPX because this is the IBM protocol. So you always see IP. So if you assign all IP into VLAN 5, doesn't make sense. Not so useful nowadays. So another one, last one is policy based. It is based on the port plus MAC plus IP subnet base. Depending on these three criteria, you assign to this VLAN. Okay, so but this means there's more configuration need to be done, but always depends on your requirements. Okay, but nowadays we just use a port base or MAC base. Port base, mostly we are using port base, but when it comes to the like voice VLAN or something, or you actually you want that host always connected to that VLAN, so you use MAC base. Okay. Or some other example, it can be your administrator. Maybe your administrator is can do management. Okay, device management. You only access using a VLAN, let's say VLAN 1. Okay, VLAN 1. Okay, management VLAN. So everyone, all the other end devices or your client or other departments, they connect to the port and then they just following. Okay, if you are connect to the ports inside the let's say HR department. Okay, you are in HR VLAN. So means all the ports are like this. So maybe if you are your laptop, if you are the network administrator, your device, your device always connected to the management VLAN, no matter where you are. So you can configure a whole switch. Okay, if the switch sees this MAC address of your network administrator laptop device, you see all this MAC. So assign to management VLAN 1. Let's say VLAN 1. So this is another example you can use. Next one. So to configure VLANs, create a VLAN first. So create a VLAN is a very easy, very straightforward command. Just a VLAN space 10. Then you create a VLAN 10. And then, or you can create because you can either create VLAN 10 and then you quit. Then VLAN 2, quit. VLAN 3, quit. VLAN 4, quit. Too many steps. So you can just create by batch. VLAN space batch 2 to 3 means 2 and 3. If 2 space 3 means 2 and 3. Also, if you have, let's say 2 to 5 means 2, 3, 4, 5. By integer, there's no 2.5, 3.5, no. VLAN 2, 3, 4, 5 is greater. If you put 2 space 5 means 2 and 5 only. Okay. After you create the VLAN, then you can assign this VLAN into the VLAN ID of each port. You can use this VLAN ID. Okay, 10, 2, and 3. So after you created the VLAN, you can use display VLAN to check. Okay, there will be a VLAN 2, 3, and 10. Display VLAN. This is a very important command. Display VLAN. Then set the port link type. Each of the switch port, you want to set it as a hybrid port, trunk port, or access ports. So by default, all the Huawei switches are hybrid ports. So these are the standard command. So you go into the interface. So let's say this port G1. Now put port, link type. Okay, what you want? Trunk port, hybrid port, access port. You can just put trunk, enter. Then this is become a trunk port or a G5 connect to the end devices. So port link type access, then done. Okay, but this is we still haven't configured the VLAN ID yet. Huh? This is so means that this is just a VLAN 1 trunk port. This is a access VLAN 1 access port. Okay, so now you want to change the VLAN ID of access port. So you can go into the VLAN, you created VLAN 2, let's say VLAN 2, and then you put port G007, okay, your port number. Or this method is the most commonly used. You go into the interface G5, and then this is a command just now I already mentioned, port link type access, then port default VLAN 3. Port default VLAN 3. This is the most commonly used method rather than this. Both works. Next. So after you configure the port type, port link type, and the VLAN ID of the ports. So you display VLAN, now you can see G7. Okay, G7 can untag VLAN 2. G5 can untag VLAN 3. So VLAN 1, right? G1, because G1 is always, this is a trunk port, VLAN 1 trunk ports. So this port can untag VLAN 1. So this means that this is the access port. This means that this is an access port. Okay. Or here, the information in this, it doesn't tell you the port is what type of port. It doesn't tell you. It just tell you what are the behavior of this port, what this port can do on each when it's on different this VLAN, what it can do. Okay, next, trunk ports. So we can put porting type trunk, and then to change the VLAN ID of the trunk port. Port trunk PVID VLAN 10, and then you put port trunk allow pass VLAN what and what. You can put allow pass VLAN all, but the all doesn't mean the 1 until 4094 all the 4094 VLAN are no. It's just the VLAN that you recognize. What the VLAN you see it here, 1, 2, 3, 4. This means the all. Okay. And then after you configure this with allow pass 2 and 3, G1 allow pass 2 and 3, you see, G1, that means allow pass 2 and 3. You will see this. Next. So for access port and trunk port is more easier to understand. Okay. But for hybrid port, it's more special one. So, but the concept is already fixed. You just have to try to look at it or try to do some labs. Get yourself more familiar with the behavior, then you will know. Okay. So port link type hybrid. Then you can change the PVID. Port hybrid PVID VLAN 3 in this port. And then you also have to tell the port hybrid, untag yourself, untag VLAN 3. Then only you have to put these 3 commands. Okay, these 3 commands. Then only this port is act like a VLAN 5 access port. Okay, and then for G7, Also, these three command VLAN 2, attack VLAN 2. This is a act like a VLAN 2 access port, but this is still a trunk port, hybrid port. Sorry, hybrid port. So next one is a hybrid type port, means you use the hybrid port like a trunk port. So this G1, you put port link type hybrid, okay, tag. Tag, you can say tag is less like allowed pass. Tag VLAN 2 to 3 means 2 and 3. If you 2 to 5 means 2, 3, 4, 5. Same thing. So trunk links using the hybrid port link type must enable tagging of VLAN frames before forwarding. Okay, so that you can see here, G1 at 2, G1 at 3 means allowed pass. Okay. Okay, so for this trunk link, either is let's say between switch we call trunk link, between switch and end device called access link. So what port can achieve trunk link? Trunk ports and the hybrid type port. Okay, can achieve the trunk link, can create the trunk link, and access link and or the hybrid untagged port can create the access link. Okay, access port and the hybrid untagged port. So it means that hybrid port can do both. Okay. Trunk, hybrid port, validation done. Okay, now this voice VLANs are MAC based. So voice VLAN are used to distinguish, isolate, and prioritize voice traffic over service traffic as a means of quality assurance. Okay, so this configuration is at switch B G1, not A. So VLAN 2 interface G1 at here, and then put the voice VLAN 2 enable voice VLAN mode auto and quiz, and then voice VLAN MAC address, this one. So this is a MAC address and this is the mask. This means that FF means mask match. If any IP, any frame, the source MAC address match 001122. Behind, don't care. Okay, because all the behind 6 digit is 0. 0 means don't care. You just care about the F. The F is the indicator. Mask match 001122. This frame will be tagged with a 6. So 6 for the for the quality of service. For this VLAN we have 0 until 7. Okay, 0 until 7. So it means that this is the this one. This one, PCP. Okay, PCP is 3 bits. 3 bits. So you can show 8 numbers 0 until 7. So 0 is the best effort. 7 is the most urgent. So that you can. So from here you can see that voice VLAN is default to 6. So it's a But urgent is quite urgent, but not the most urgent yet. But compared to the service traffic, like less effort 0, this is far more urgent. Okay. So if a trunk link has a PVID of 5 and the command port trunk,
Mr. Bay,
yes.
the voice VLAN description remark is what? What is 46 for?
46, you see, this is a DSCP, the DS field in the IP header.
Okay.
This is also for the quality of service, the class. Okay, both are for the class. Okay, means that more urgent means there will be forwarded first. Okay. So allow pass 2 to 3 is used. Which VLAN traffic will be carried over the trunk ports? The trunk link have a PVID 5. Command port trunk allow pass VLAN 2, 3 is used. Which VLAN traffic will be carried over the trunk? Is 2 and 3 only, not 5. Because if you want to 5, you have to add a 5 in the command. If not, cannot, even though same PVID. What action will be taken by an access port of a PVID of 2 when receiving an untagged frame? When a VLAN 2 access port receives an untagged frame coming into the switch, you will tag the frame with a VLAN 2 tag. So now go to the ENSP. Okay. So this is still one broadcast domain. What we want to do is put the PC1, or I should mean this port and this port is in VLAN 10. This and this is VLAN 20. Means PC1, PC3, VLAN 10, PC2, PC4, VLAN 20. Okay, and then access port, access. But for between the switches, this is already an ether trunk. So both sides we configure the trunk ports. But the PVID we don't change, just let it 1. Trunk ports. And then we put allow pass all. Okay. So configure until here only. Okay. S1, S2, S3. So you can configure now based on the configuration here. You just do this, and this. Only 3. The VLAN routing we'll do it later after the next topic. So you can start with creating the VLAN batch 10 space 20, pin 10 and 20 only. And then you go into the ether trunk 1, change the port link type to trunk. Okay, and then port trunk allow pass VLAN all. And then go to your G5, porting type access, port default VLAN 10. Go to G6, porting type access, port default VLAN 20. Okay, and then go to S1. S1 is your core switch. So VLAN batch 10, 20 also need to create it. Okay, 10, 20, 10, 20 need to create both. Both switch also need to create so that the allow pass can work. Allow pass. So we do it on both ether trunk.
Mr. Beck.
Yes.
Sorry, in that summary, the second part. Is it a straightforward answer that since it's untagged, it's going to be forwarded to the host, or if it's from the host,
Which one? What action? What action will be taken by access port?
Yeah.
With a PVID of 2 when receiving an untagged frame. What action?
It's already on tag, so it's supposed to forward, isn't it? To the host.
Untag. A switch port receive a untag frame.
Oh, okay. I didn't see the switch there. There's nothing indicating switch there.
Access port.
Of the switch, isn't it?
There's the router don't have access port is for VLAN. VLAN. Okay. Okay.
Yeah,
So,
I know. So what I'm saying is, if it's coming to the switch and then directed towards the port PVID2 on an interface, is already, since it's on tag, isn't it supposed to forward to the host?
go to the host.
Supposing it's coming through to a switch and then the switch is forwarding to a host on the switch.
This means this access port VLAN 2 or is it, let me look here. See PVI2 access port.
Yeah.
What happened? Coming in. So coming in the switch back the frame with a 2. Correct not? This is action. This is the action. That's all. Or
No,
you want to add on, or you want to add on, maybe the switch, maybe forward the 2 out to another access VLAN 2 access port. You can add on further the answer.
Okay. All right. I was wondering whether at what point are we looking at an access? Is it an access? Is it
Coming
connecting
in, receive. You already right. Receive. Receive the switch. Receive the untagged frame. The switch receive an untagged frame on the port. This is going to forward out. This is not receive. This is giving out already. Giving out.
Yeah. Okay.
Okay. This is receive. I'm taking something coming into me. Okay. Receive.
All right.
Yeah. This is giving out, not receive. Okay. Okay. So we continue from here is a VLAN batch 10 and 20. Always create the batch, create the VLAN so that your allow pass can work. Allow pass all. So and then 5 and 6, say 5 are VLAN 10, 6 VLAN 20, access. Okay. So you can do it now. So or for me, I just copy everything. This is S2. Okay, I copy one by one. I open S2. S2. Let me do the VLAN batch and the trunk port first. Just type. Okay, maybe better for me to explain. So I S2 system view. VLAN batch 10 space 20. And then display VLAN. I can see 10 and 20 is created, but there's no ports at here. Nothing at here. Okay, nothing. So all the other ports, there's no G1 because G1 is inside the ether trunk 1 already. So next will be display port VLAN. Display port VLAN. This will tell you the link type, port type of each of the ports, and then what is the PVID. And if this is a trunk link, what are the VLAN that is allowed to pass? Okay, so I just created the VLAN. Now I go into the interface, ether trunk 1. Ether trunk 1. So and to put port link type question mark. I can have access port .1 queue tunnel or queue in queue, doesn't matter yet, don't care about this yet. Hybrid and trunk, access hybrid trunk. So I want to use trunk. So then port trunk, what I want to do, port trunk, I want to allow pass VLAN, which one? All, I just allow pass all. Or before this, I don't do, copy this, I don't execute this command first. Okay. Not yes. I just configure the port link type to trunk, and I display VLAN again. Display VLAN. Same. Either trunk 1 can untag VLAN 1. I display the port VLAN. Port VLAN. You can see either trunk 1. This time we can see the trunk 1 here. Before this, nothing. Trunk dash. Because this is still a hybrid port, VLAN 1 hybrid port. So, but now we configure it to trunk PPID 1 by default, but VLAN 1 is allowed to pass by default, so it will show it here. So if I put the command port trunk allow pass VLAN all, I display VLAN, I can see E1 can allow pass, or E1 or either trunk 1 can tag 10. Either trunk 1 also can tag 20, means allow pass 100 tag. So again, display VLAN, it will here, it won't tell you what is the port type of the port. You always can check again, always verify again with the display port VLAN. And you know, okay, trunk port VLAN 1, allow pass 1 to 4094, allow pass all. But the all means the VLAN you recognize, which is 1, 10, and 20 only. So if you want the port, trunk port to allow pass other VLAN tag frame, you just have to create the VLAN only, that's all. Again, I display this to look at what the configuration I apply on this ether trunk 1 interface. You see, port trunk allow pass VLAN 2 to 4094. Because here only show the configuration you done. It will not show the default configuration, because VLAN 1 is already allowed pass by default, so you will not see it here. Okay, you only see VLAN 2 and 4094. Okay, and then I go to interface G005, port in type, access. Okay, and then I'll change to port default VLAN to 10. Okay, port default VLAN to 10 and G6 port default port link type first. Port link type access port default VLAN 20. Okay, display this, always display this to check. Yes, port link type access port default VLAN 20. Okay, then display VLAN. Now you can see G5 can untag 10, G6 can untag 20. Then display port VLAN. From here, 5 and 6, access, 10 and 20. Done. So we are done for S2. So go for as 1. So as 1 is just to configure the either trunk 1 and 3 to trunk port and allow pass all. So system view interface is the trunk 1. Okay. Then port link type trunk, port trunk, allow pass VLAN. Oh, this is a shortcut. Okay. You just type the first word of each syntax. So go into the trunk 3, you can just press up, port link type trunk, port trunk allow pass VLAN all. There I can always use the display VLAN. Okay, but it doesn't see my 10 and 20. So I must create it so that it can allow to pass. So VLAN batch 10 space 20. Again, display VLAN. Yes, see. So 1 and 3, 1 and 3. That 10 and 20. Equal 1 here. But 1, because this is a trunk port, so you untag 1. Because this is still a VLAN 1 trunk port. So display ports VLAN. So we need to enter trunk, stay at default VLAN 1, allow pass all. And go to S3. View. So you know the save time I just copy everything and paste it. 3. So view already. Paste, enter. Okay. So display VLAN. Okay, I have 1020. My ether trunk is tag 10 and 20. Okay, ether trunk 3 also untag 1. And then my G5 untag 10. G6 untag 20. Okay, so it's done for the VLAN. So this time, this is my Wireshark at here. So again, I try to ping my PC3. I can ping. So, but this time I don't see the ARP broadcast anymore because I separate the broadcast domain using VLAN. So, how is the frame looks like? So we can check. Capture data. Let's say G1. So again, I try to ping PC1, ping PC3. We will see a VLAN 10 tag free. So I put not STP. Okay. So you can see this one sent out by PC1. You can see the Ethernet, the Ethernet to header, E2 header, and then I can see this. Actually, the type here, type. This is what actually we see. So your Ethernet to header, you see a destination, source MAC, type 802.1q word VLAN. This is a standard. And then the number represent is 8100. So means that the next header is the 802.1q VLAN header. So inside I have a PRI or the PCP, best effort, 0, best effort, and then DI, no. Okay. Then this is the most important one, the VLAN ID. VLAN ID. So 1010 means 8 plus 2, 10. And then it will show that what is the next header. Next header is IPv4. So the reply also the same. 10 VLAN 10 tag. Okay. Okay, so that's all for VLAN basic principle. So the VLAN routing will go into the next topic. So leave this one, I minimize. Okay, VLAN routing. Okay, so why do we have VLAN routing is this? VLAN, the disadvantages of VLAN is, yes, we use VLAN to separate the user, to separate the broadcast domain. But separate broadcast domain means also means that we isolate the user. So this is to isolate the user. This can mean advantage, also can mean a disadvantage. Okay, that depends. So this VLAN 10, VLAN 100, VLAN 100. So they are connected to the same switch. Means that maybe here are VLAN 100 access port, VLAN 200 access ports, but they are isolated. So what if I want both PC from both VLAN can communicate? That's like you communicate over the router. You need a router, layer 3 device, a router to route your packet from one network to another network. So can I do routing at here? Yes, I can still use a router to do the routing, to route the packet from VLAN 3 to go to VLAN 2. VLAN frames are routed over a trunk link for port conservation. Less port is used. I only use one trunk port. I send everything, all the tag frame, all the track frame, doesn't care what is it from what VLAN, doesn't care which is from VLAN 2 or 3, doesn't care. I just send to router, then router send it back. When router send back, I also doesn't care what is the VLAN 2 or 3. I just receive and forward according to the access port VLAN ID. Okay, so what has happened if we are just using a trunk link to a router? What happened? So you can see on the router, or you go to the host first. Host again. For a host to go to another network, they must have a IP address. IP address of the gateway IP address. But means that VLAN 2 have a gateway. VLAN 3 also has its own gateway IP address. That's the IP address. So whatever host A want to send to host B, host A will forward to his gateway, which is 192.168.2.254. Who is it? It's a router A. Host B, gateway 192.168.2.4.254. Who is it? Also router A. But here only have one interface. Okay, again, in the physical interface of a router, you can only assign one IP address. I should say one IPv4 address. Okay. So what happened here is actually we use a subnet interface. Okay, sub interface. I can have G001.1, G001.2. So .2.1, I assign the VLAN 2 gateway IP address .2.254. For .2 inside interface 1.2, I assign the IP address of the VLAN 3 gateway IP. Okay. So what has actually happened in this is, let's say VLAN trunk here. Okay, so let's say host A want to send the data to host B. Host A will send out a untagged frame. Okay, go into the switch A will check. Okay, this is a VLAN 2 access port. tag the frame with a 2. Okay, and then this one, when we come to the trunk port, the trunk allowed to pass. Okay, then these two can send to send to router A. Router A receive at port. Okay, let's say port. Oops. This one go in to go out. Still send to the router A at this trunk ports at this sub interface. Okay, 1.1. 2.254. Okay, router check going to 2.254. Okay, so destination is .3. Maybe .3.1 for host B. So router A check the routing table and then you know what to do. Okay, then what you do is you change the VLAN tag into 3, and then send to the switch trunk port. Trunk port coming in because this is the trunk ports. You also need to allow pass VLAN 3. So this is a VLAN 3 tag frame. So it cannot go out from here anymore, but he can go out from VLAN 3 access port here. So how the router do the VLAN routing? By change the VLAN tag. Okay, so these are the configurations. And here, the first one, create the VLAN, and then access port, put the access port to VLAN 2, access port to VLAN 3. This is easy, you already done this and this and this. But on the trunk port, you recommend to allow pass VLAN all. After that, on the router side, how to configure on the router side. So you should configure create a sub interface, G001.1. Okay, and then you put in the .1Q termination VID2. VID2 means the VLAN 2, so that this port can untag VLAN 2 frame. Okay, the .1 doesn't matter. This because this is just a port number. Doesn't matter. Most important is inside here. .1Q termination VID2. And then what is the IP address for your VLAN 2 gateway? IP address 192.168.1.254//24, and then we have to put ARP broadcast enable. Okay. And then you go to another sub interface. Also, .1Q termination VID3. And then IP address of your VLAN 3 gateway 192.168.3.254. And also ARP broadcast enable. Okay. So that done already. Okay, it's done. So I didn't put the command here, but I can demo. Okay, just demo the command for you, and you can check. Okay, I'll go to S1 G5 S1. So for switch side system view interface G00 G5. Okay, port data trunk, allow pass VLAN all. Okay, and then you go to R1 G0. So system view system R1. So because R1 just do the routing and that, so R1 don't need to create a VLAN. So what you need to do is interface G000. Let's say if avoid to confusing yourself. If you are doing for VLAN 10, just put .10 or just a question mark. You can put 1 until 4096. Let's go 10. Okay. And then .1Q termination VID 10. Okay. And then ARP broadcast. Okay. Enable. So that your sub interface can send ARP broadcast to look for the MAC address, okay, of the host. Okay. Then the interface G000.20. Again, the port number doesn't matter, but to avoid confusing yourself, always recommend to use the same port number with your VLAN ID. Okay, VID 20, and then the broadcast. ARP enable. Okay, so almost forgot the IP address. Okay, res 20.0.0.254 space 24. Interface G00.10. IP address 10.0.0.254 space 24. Okay. So now either side, either S1 or R1, I capture the data. So I want to see the change, how the router changed the VLAN tag. Okay, I filter the SDP, not SDP. And go to PC1, the ping PC2. Ping 20.0.0.1. Okay, success. Let's check the this. Okay, so ping request, no reply. Reply in next one. So this is what we have. 10, no reply. Okay, so this one sent by PC1 with VLAN ID. Oops, this is the request. Oh, this one. This is the first one sent by the PC1. Okay, PC1. So it's the VLAN ID 10. VLAN ID 10, and then sent to the gateway, means to the router. So router change the VLAN tag to 20 and send to PC2. Okay, PC2 reply with also VLAN 20 reply. So again, R1 change the tag, okay, to 10, VLAN 10. Okay, then send this reply to PC1. So keep on repeat. 10 change to 20, 20 change to 10. Okay. So this is how the router and stick architecture do. Okay. Next. Okay, or you can just use a layer 3 switch, L3 switch based VLAN routing. So this is a L2 switch with a router. So this will be less equipment. So L3 switch based VLAN routing. So VLAN if this time we introduce a VLAN if are used by each VLAN as a route gateway. What to do is on each of the switch you configure the VLAN interface. So means that one switch, if you have a VLAN 2, means that you can create the VLAN interface 2. If you have VLAN 3, you can create a VLAN interface 3. Means that all these three, all the PC, all the end devices connect to that port with that PVID or all the end devices connect to the VLAN 2 access port are also directly connect to the VLAN interface 2. Means this can be the gateway. Okay, so go back to the configurations. So now I have to go to R1. I have to remove the sub interface. So undo interface is 000.10. Undo .20. Yeah. Just now, after I create the sub interface, I should show you the display IP interface brief. You will see the sub interface here. I miss it. So maybe next time you try to do it, you can try to check again. So for R1, okay, done. So in S1, okay, what I should do is this S5 display this. Let me change this. Okay, undo. Just leave it. I just leave it. Okay, later I'll do it later to change anything. So now I have to go into S1. So before I create the VLAN interface, I can use display IP interface brief. Here I can see I already have a VLAN interface 1, but I don't configure anything on it yet. So but I go to interface VLAN if, let's say 10. So IP address 10.0.0.0.254 space 24. Okay, up already. So and the one VLAN interface VLAN if 20. So IP address 20.0.0.254 space 24. Okay, display IP interface brief. I can see VLAN if 10, 10.0.0.254, VLAN if 20, 20.0.0.254. So display IP routing table. Yes, we have routing table, layer 3 switch. So I know where is network 10.0.0.0 and 20.0.0.0.
Come back before you close.
I'll choose 3.
But you don't.
So I still go with PC. PC1 have ping PC2, still can ping. So I check the duplicate use of no. Doesn't matter. I change it. Again, maybe it's gone later. Sent by who? B459 B3. B459 B3. Who is this? Oops, already erase everything. S1. The configuration is correct. R1. No. So what happened here? Again, type of pin. Can pin, yes, can pin. Oh, this one is this one. I look at the wrong Wireshark capture, so I capture it again. Yes. this one. Okay, so we look at the first one. It's sent by PC1, and then it's a ping request sent out at VLAN 10. So this is sent to S1. So S1 change the VLAN ID to 20, and then send to PC2. So PC2 reply with a VLAN 20, and then this S1 change to VLAN 10 and send to PC1. And also one more thing I have to show you is this S1. The MAC address table S1. What do you see? Display MAC address table. Oops, display MAC. You can see from here. So this is PC1. You know that PC1 is what? VLAN 10 from Ethertron 1 dynamic. PC2 is VLAN 20, Ethertron 1 dynamic. So in your MAC address table, switch also record is it VLAN 10 or VLAN 20. So this is done by switching. VLAN routing done by the layer 3 switch, we still call it switching. So what you do is the layer 3 switch still look for the routing table to know that I should if this destination for PC2, you will check, okay, destination PC2, I should change to VLAN 20. So we change the tag to VLAN 20 and send out. So you can see that if VLAN routing using a layer 3 switch is far more easier, straightforward compared with the router, using a router on a stick. Okay. So that's all. So what is the purpose of the .1Q termination VID in the command? So we can just say that it's so that the router side interface can untag the VLAN frame, so that can untag and check, and then can check so that the router can check the IP address. The destination IP address. So what is required to be configured on the switch to allow VLAN traffic to be forwarded to the configured sub interfaces? So this is the trunk port. So below here, just extra command is for you so that now everything go to S1, and then S1 is sent to the other devices. So this is still inside the VLAN, inside the private networks. So what if all this, all the PC, you want to go to access the internet. Let's say R1. R1 is a router that connects to the internet. So the traffic that need to access the public network, the S1 had to forward to R1, because S1 is the gateway. It's the gateway for all the end devices. So S1 for S1 to forward everything to R1, you need S1 to configure a default gateway also, same like the PC1. Okay, same like all the end devices. So S1 we configure the IP address of this. So I can go back to R1. Let's say R1. But R1, because I have to, I want S1 can send to R1, so they need to be in a one broadcast domain. So I use the VLAN interface 1 to connect to R1. So it will be G5. I just have to put G5 into the VLAN interface 1. Okay, let's say the interface G005. Split this. So I should undo this. 2. Then port link type access, port default VLAN 1. So I change this back to VLAN 1. Okay. Okay, so display port VLAN. I know that port 5, access 1, done. So I have to configure the IP address. 192.168.1.1. Okay, to the VLAN if 1 interface VLAN if 1. So IP address 192.168.1.1 space 24. Okay. For display IP interface brief. Let's see VLAN if 1 192.168.1.1.1 space slash 24. R1 also interface G00 IP address 192.168.1.254.1.254 space 24. Enter. Okay, to ping 192.168.1.1 S1. Yeah, success to ping. So whatever sent by the end device want to go to the internet, S1 should forward to R1. So at S1, I create the static route, like a gateway, it's a gateway for S1. 0. So 192.168.1.254. Okay. Success. So display IP routing table. However, default routes to R1. So PC1 now, PC1 can ping anything, ping 1.1.1.1. So it doesn't exist. But router 1 will still receive. What is router 1? This one. No response. This is being forwarded to R1. ICMP request. Because for PC1, the default route is sent to S1. For S1, the default route is sent to R1. For R1, don't know how to go to 1111, so no reply. So, yeah. Time request time up. Okay. So, what about PC1 want to ping R1 so that everything we need to make sure R1 can know how to go to or this PC. Okay. So we go to R1, display IP routing table. So we don't see any 10.0.0.0 here or 20.0.0 here. So it means that R1 doesn't know how to go back to this. It doesn't know how to go, doesn't recognize any of this network, it will not able to send to forward to the S1. So it means that S1 have to share this, advertise the network to R1. What you can do is you can use OSPF. You can use OSPF. So router 1, OSPF, area 0, network 192.168.1.0.0.0.255. So you can see router 1 send a hello packet, OSPF hello packet. Try to follow the neighbor with this direction, this link, which is S1. So S1 also have to OSPF area 0, network 192.168.1.0.0.0.255. So extract. Oops. Same thing. It's the SPF here. Okay. So the form state full states for neighbor. So this .1.254 is R1. .1.1 is S1. So right here S1 still have to advertise the network 10.0.0 network 10.0.0.0.000.255. Another one net 20.0.0.0.0.255. Okay, then go back to R1, display IP routing table. See, 10.0.0 is learned from OSPF. Preference 10, next hop is S1. 20, also the same, 20.0.0.0, OSPF, preference 10, next hop, S1, .1.1. So on PC, to the pin 192.168.1.254, which is R1, can successfully pin. This is it. Okay. So this is how L3 switch, which can support OSPF, can fall neighbor with router to advertise the network, the private network. So that's all for VLAN routing. So for this command, I never change all this command, you can save it. So save it. I can save all the configuration for you also, but you don't need to save configuration also, never mind, because the configuration is on the bottom. Okay. So here I just save it. Okay. And then close this out. Or do you have any other question? Any questions want to ask about this VLAN? Any more questions? Okay, if no questions, let's proceed to the next topic. Okay, close this, yes. This one also close. This one also. So yes, please. Yes. Bala, are you
Hello,
calling
yeah,
me?
Mr. Day.
Yeah. Yes.
Yeah, I was just wondering, in my R1, when after setting up the whole configuration, when I ran it on the OSPF peer, I'm only seeing on the routing table, I can only see the 10.0.0.0. I can't see the other one.
Means your S1 haven't advertised it.
On R1. The routing table on R1.
On your R1, you can see 10.0.0, but you cannot see 20.0.0.
Exactly, yeah.
Because your S1 haven't advertised it. Go to S1 and configure the network 20.0.0.0.
Okay.
You can go to check your configuration on S1.
Okay. All right, carry on. I will do that.
Okay. So now we are going to the WAN technology. Okay, WAN technology, which we call the principle and configuration of HDLC and PPP. Actually, it says HDLC and PPP. So this HDLC and PPP is a layer 2, same layer with the Ethernet. So it means this is another encapsulation method at layer 2. So before this, we learned about Ethernet is they encapsulate a MAC address. But HCIA and PPP doesn't care about MAC address. Okay, because this is used based on the serial interface, serial ports, and serial link. Okay, so serial has in recent years been slowly phased out in many parts of our network in the favor of Ethernet technology. Okay, but no more already, very obsolete. Okay, don't care. So, but we have to know this is a legacy WAN technology. This is for you to connect to the ISP or connect to the internet. Okay, so I will explain how data is carried over serial-based media, means the serial cable. So, and we'll also try to configure the link layer protocols for serial links. Okay, later we see. So serial signaling. So you don't see the MAC address here. This is in serial cable. We have asynchronous and synchronous. So asynchronous, we can do the host can send data to router anytime. Okay, but included with a start bit and a stop bit. In the middle is the data. And then synchronous mode will need to have a clock at the ISP side. We call DCE. DCE is the ISP. So DT is the client side, customer side. So customer have to follow the clock on the ISP side, provider side, and then we have a flag, data flag. This is how data is being encapsulated in synchronous mode. And then the HCIA protocol. Okay, this is how HCIA protocol looks like. So in Huawei router, we only use these formats. So the information, so information, we see the flag. This is a synchronous, but this, so this HDLC. You see the address. We show the IP address, the control, and then the data is here. And then you still have the SCS. Okay. So basic configuration of HDLC: 2 router, 2 ports, 2 serial port connect with a serial cable, and then you put the IP address, and then on the configuration on the ports, interface serial 100, link protocol HDLC, because by default is PPP. If you want to use HDLC, put link protocol HDLC, yes to change, and then put IP address. Both sides do the same, and then you can ping. Or you can borrow serial interface, link protocol HDLC, yes, and then IP address. What is IP address? A number. Borrow from interface loopback 0. So you can see this is 10.1.1.1/32. You borrow exactly the same thing, including the subnet mask. 10.1.1/32. Then you can ping. Then check display IP interface brief. You can see the IP address. Okay, interface IP address both, and the serial one is the same. So another one protocol other than HDLC, we also have PPP. Okay, so PPP point to point. Okay, point to point protocol application. Okay, a multi-protocol standards used as with HCIA to define the link layer operation of a serial medium. So PPP is another standards to define link layer operations. Same just like the Ethernet, Ethernet 2 over a serial medium. But Ethernet 2 is used on Ethernet cable. PPP and HDLC is used on serial cable. So let's see what are the method components of PPP. So PPP is we have the PPP encapsulation methods. So define the format to be used when supporting encapsulation of upper protocol, such as IP or IPX. So later we will see how the encapsulation is done. Okay. So link control protocol, LCP, okay, define the method of establishing, configuring, and testing the data link connections. Okay, and then we have another one, NCP, okay, network control protocol, defines a set of protocol for establishing a net connection for negotiating parameters for different network layer protocols. So LCP is for data link connections. NCP is for network layer connections, network layer parameters. So PPP link establishment process. So both sides, both PPP. So what's the advantage of using PPP is both sides, even though you're connected, both sides is not up, you cannot straight connected and straight start to send the data yet. Even though both sides you can already configure the IP address, but you still have to go through this establishment process. So what's so special about this establishment process is this one, the authentication. So both sides start from that, and then they go into established stage. Up, established stage. In established stage, both sides, both router, negotiating the parameters, the LCP negotiation parameters. So what are things that need to be negotiated? These are the three things. The MRU, so maximum resource unit by default 1500. Authentication protocol. So by default is no authentication. You can choose either want to use chat or PAP, CHAP or PAP. Later we'll see what is this. These are just this is the authentication protocol, and this is the main point of using this PPP. Okay, and then magic number is to trace is there any loop detection, any loop in the network. Okay, magic number. So these are the protocol message, protocol packets used to negotiate the three parameters. Okay, configure request is the client side. Initiate the connection. I want to establish a PPP connection with the server side, with the server router. Client router, server router. So client router send a configure request, propose with this MRU 1500, and then the authentication protocol maybe is none, and then maybe the match number, just put a random number, send to the server router. Okay, and then if the server router reply with a configure add, means that the server router agree with everything, all the three parameters, and then they proceed to authentication stage. Okay, but what if, okay, before that, scroll up first. So this is how the LCP, all these config packet, all these 4 packets looks like. It's like this. Okay, flag, address control protocol information is the data. So I have the LCP packet format. Data inside data is this. LCP configuration option format, the data, all this. Okay, so let's say if the server router doesn't agree with the number, some option with the numbers of some values on the parameters. Maybe the server router 1400, or maybe the magic number. Is because maybe the router received the 2 configure requests with the same magic number, means loop already. There's a loop. So to reject, no, to cannot say reject, rather reject is this, configure reject. So to not acknowledgement, okay, to tell the client router, please change another MRU or change another magic number using this, change the number. So configure net. If the server router doesn't agree with some of the options, you can say maybe all the options are, I don't agree with the authentication protocol. Maybe the client router saying, okay, no authentication, but the server router want the CHAP authentication. So she send a reject to tell the client router change your parameter. Okay, if you don't change, keep on reject. So they negotiate until again confirm until the server router agree the 3 parameter and then send a configure X. Okay. Then go into authentication. If there is the authentication is none, then it's none. Straight go into the network stage. So it's failed, you go to terminate, down and go back to that. Again, also an SLB stage, if failed, also go back to that. Okay, let's say we choose the client router already configured with some authentication. See, they want to use authentication protocol. Okay, so this is the configure request and configure add done. This is success. If something happened with the number, so our router B send a configure net, router A modify the parameters and then send another configure request. So if something happened, some options not agree, router send a configure reject, and then router A send again remove unrecognized parameters and then send another configure request again. Next, so to configure it, this is PPP. Okay, link protocol PPP on the serial port. Then yes, but by default it's already PPP. So IP address, put IP address, subnet mask, put. Okay, configure. Okay, now let's say both sides decide to use PAP. So decide to use PAP, and you will see this. Okay, authenticated in the server side, the server router authenticated. This is the client router. So client router will send the username and password in plain text to the server router. Server router reply with an authenticate add or authenticate net to indicate success or unsuccessful. So if success, they go into network stage. If not, it will be failed. Go to terminate. So if you want to use CHAP, the server router will send a challenge as a random string of number. So the client router side will use the challenge to use the challenge, then combine with a password, which is its own password, and then use hash with an MD5 algorithm, and then come up with the answer. The answer, the client router will send it together with the answer with the username as the response sent to the server router. Server router also, because server router also hold the username and the password for router B for the client router. So the router will know, okay, if I use these passwords and then combine with the challenge and then use the MD5 hashing algorithm, I will get the same answer as what the client router sent to me in the response. So I compare both answers, compare, same, I send success, fail, failure. So if success, both sides will go into network stage. Network stage will do IPCP or NCP negotiation using the IPCP protocol, Internet Protocol Control Protocol, used for establishing and configuring IP. So we have static and dynamic. Static is both sides have a fixed IP already configured with IP. So router A send a configure request to tell router B, I will use 10.1.1.1. Router B reply, configure yes. Router B also said, I want to use 10.1.1.2. Router A configure and yes, you can use. Then done for static negotiation. So then they can start to send data. And then if dynamic is the server side have a IP address, but the client side no IP address. So configure. So this is just a scenario, just like you want to connect to an ISP to the internet. So you always ask for IP address from your ISP. Maybe it's a public IP. So you configure request, no IP address, empty. Okay, no IP address. So router B send a configure net. You shouldn't use this 0000. Please use 10.1.1.1. So router A configure request. Yes, I want to use 10.1.1.1. Router B say okay. Then configure. Router B also again configure request. I want to use 10.1.1.2. So router A configure yes. Then they can start to send data. So these are the configuration for PAT and this for chat. So following a configure request, what packet type is expected to be received before the PPP link layer can be successfully established is the configure ACK. And then which protocol is used to perform the negotiation of IP address and during which phase is this negotiated? Okay, protocol is the IPCP. And then the phase is the network phase, NCP phase. So, and then again, what's the advantages of using this PPP is the link is we can have authentication stage. Means that both sides, even though your cable is good, works, your port works, you connect both sides, are not able to send data if you are not authenticated. This is different with the Ethernet, because Ethernet, you just connect both sides with your UTP cable or the fiber cable. You connect both sides. The connection is out, then you can start to send data. There's no authentication. Means that. Okay, so this is the advantage of using a PPP. So these are the let's see. PPP. Okay, this topology I also add into the what's the WhatsApp group. I share in the WhatsApp group. See. Okay, here I'll just demo for you. So, and later when you have free time, you can try to do it again. So this PPP, I want to capture and to see the packets. So as you capture PPP, yes. So there's a echo request, echo reply for heartbeat between two. Okay. 2 serial ports. So let's say PAP. PAP is the PAP server. Server is the, let's say we want to use PAP authentication. So PAP server is the authenticator. Let's change. So authenticator. Let's change the sys name. Host name change to PAP server. So and then I have to create a username and password. I use AAA. Local user Huawei password cipher is 123 password. So local user service type, you can use this service, this username and password for service type PPP. And then go to interface, configure the IP address, and then link protocol PPP. This is already default. So PPP authentication mode, PAP on this. Okay, so I configure this. Copy. System view, paste. Okay. So for chat side, we don't care about the chat server first. Let's say we use this as a client. So this router as a client. We also configure with a sysname. Okay, configure with a name. Okay, configure name, and then configure the IP address interface S000 IP address. Link protocol PPP. Okay. Okay, done. So as a PAP client, you need to also configure the PPP PAP local user Huawei password cipher 123. So that this interface serial S0, you can use this username and password to set up the PPP connections. So this one. Copy, paste. Okay, so you can see this is exactly same with this. Just from here. Here, this one, and this one. It's exactly the same thing. So let me see. Do we have a shark? Don't have yet. Let me S0 shut down the ports. Then we undo shutdown. We will see the result. Okay, undo shut. Okay, see. Okay, done. Configure request, configure add, configure request, configure add, the LCP negotiation, and then the authentication stage. Huawei 123 vertices PAPs. The username and password is sent in plain text. So authentication add success because. So and then configure request, configure add. This is the IPCP. Okay, see IPCP. And then success everything, start to send data. Okay, let me try to ping. Okay, PAP, try to ping 10.0.0.2. Okay, success to ping. This is the ping request. So you can see there's no Ethernet tool, but we have PPP protocol, point-to-point protocol. Okay. Address, control, and then protocol IPv4. Shows that the next header is the IPv4. And IPv4, still the same thing, no change. Go, ICMP only one. Okay, only can send to one. Okay. So I changed some of this. So I want to undo this PAP server. Let's see, undo. Okay. So not here. I want to configure. Okay, this one I also undo this also. Chat server. Undo. Okay, display this. Okay, no more. So this time, this will be the authenticated chat server. So here I should insert this PVP authentication mode chat. Is server side. I should include the PVP chat user Huawei, PVP chat password cipher 1 into separate into two because the password will not be sent to the authenticator. Only the username will be sent. Copy. Paste. So shut down. Shut down. Okay. Oops. Okay. This also need to be configured on server sides. Okay, great. Okay, so start from this, configure request, configure add. Okay, and then I'm going to LCP and this LC. Okay, LCP negotiation success. Go to authentication stage using chat challenge response success, and then IPCP. To negotiate the IP address here. So I let you see options, IP address, this one. So this is sent by the chat server. This is sent by the patch server. Okay. Then after this also success, start to send data. Okay. This is a magic number. Okay. So that's all for this PPP. So any questions? Huh? So nowadays we no more using this PPP, but not direct. I cannot say not using. We're not directly using PPP only. We integrate this PPP into another technology together with another technology, which is this one. PPPoE, point-to-point protocol over Ethernet. Because we still want to use the Ethernet, because we want to use the Ethernet, because the Ethernet now, the Ethernet can go up to 800 gig by next year. Okay, so 800 gig. So you can say that Ethernet can provide a faster speeds, higher bandwidth, but it doesn't provide authentication. So we use PPP over Ethernet so that we can have high bandwidth. We also can have authentications. So, so I'll describe the PPPoE connection establishment process and configure. I will demo a PPPoE session for you. Let's see. So this one I can save. I open another one. PPPoE. Okay, I also share the PPPoE topology in the WhatsApp group. Please download it. So here I will just, you don't need to open that, but here I just demo to you because in the exam they won't ask for the configurations commands on the this PPPoE or even the PPP. So I just demo for you. Okay. Then let's say digital subscriber line (DSL). This last time this is a successive broadband technology following the dial-up. Okay. Data signal carried over the copper telephone lines, or we call it local loops. So what happens is inside your home or your office, you have a cable. Maybe it's a, if you DSL, this is using a telephone cable. Okay, connect to the DSLAM. Okay, DSLAM, and then this is the ISP equipment. Okay, then this LAN connect over the underground cable, go to the BIRA server. This is the PPPoE server. Okay, then inside your house there is a PPPoE client. So this is how you connect to the ISP, and then you can connect to the internet. So PPPoE applications in DSL. Again, inside your home or inside your office, you have your PC, you connect to the router. The router, this one is the PPPoE client. You have the DSL modem to convert your Ethernet to your modem, maybe. Okay, and then to convert to different kind of signal. So this connect to your this LAN to the ISP side, ISP infrastructure, this LAN, and then there's a BIRA server or the PPPoE server. So both sides, this and this, do authentications, and then I can access to internet. So to establish a PPPoE sessions between the PPPoE client and PPPoE server, these are the protocol packets being used to negotiate. So first one, PPPoE active discovery initiation packet, PADI. Second one is offer, initiation offer, PADO, PADR, request, session confirmation, done. The session is up when receiving this session confirmation. If the client side want to terminate the session, it also can send a terminate packet. So the stage, discovery stage. The client will send a PADI initiation. It's a broadcast to look for all the PPPoE server. Okay, then this ether type. Can you see this ether type? PPPoE ether type. Remember this. PP 8863. Okay. Then next step, server will reply with an offer. Okay, maybe please server reply with offer using unicast. Maybe more than one server will reply, but the client will just reply, send a request to one server only. Unicast also. The other server don't care. Okay. Then server receive the request, server reply with session confirmation. So server will assign the session ID to the client. So after the PPPoE session is up, both sides also still have to go through the PPPoE negotiation again. Go through the LCP negotiation, and this is the chat authentication, and then the NCP negotiation. So that's why this PPPoE. This looks how the frames looks like. Your data, TCP, and IP, and then you have to decrease the size of your data of your load, data load to 1492, so that you can cater for 2 byte plus 6 byte for this total 8 bytes for PPP and PPPoE header. So this is total 1,500 byte again. Okay, and then if the client want to terminate the sessions, send a PADT. So these are the commands. The commands not important here. Okay. Exam also will not ask. Okay, but here need to know how to read this. $R client protocol up. So you have to know. Okay, this is the IP address. That's the router get. And then the link layer protocol is PPP. Link layer protocol PPP. Okay, that's all. So how the server side differentiate who is the client? Okay, so you differentiate by using the client MAC address and the session ID, ID1. This is the MAC address. Then PPPoE application in the enterprise is like this. PPPoE client, your router, at your home, or your office. So before inside your home, you are in private network. So if you want to go to the public, this is a public network domain, you must have a public address, which you need to do address translation, network address translation to translate your private IP to public IP. Then only you can go to access the internet, because the infrastructure in the public network, they will drop all the private IP packets with private IP, because they don't know how to, they don't recognize private IP address. Okay. So why is it necessary to reduce the MTU or IO size of the PPPoE packets? Is because to cater for the PPP and PPPoE headers, 8 bytes. So to prevent packet loss. What is the purpose of the download command, bundle command when establishing the PPPoE connections? Download bundle command is just used to bundle your download interface to this one, your interface, G1, physical interface. Because you're using the download interface. So you bind this download interface to your physical interface. Okay. Then you can see a static route here. IP route static, default route, send out from this port, go to the internet. So inside a home, maybe you will use a home router, already a very small home router with antenna provided by the ISP. When you subscribe a package, you will receive this. But in the enterprise, you also can use a Huawei router, enterprise router, as the PPPoE clients. So at that moment, you will need to configure all this. If not, you can just use the GUI in the home router, home-based router provided by the ISP. Let me show you. Oops, I forget to start. Let me close this. So I just copy everything and drop into the device. Because I just want you to look at the packets. So I should copy G0. Paste. And then server side. For server side, you even will be very rare to see this command, to use this command, because this is used by the ISP. Unless you have become the ISP to configure a PPPoE server, else you won't ever come across this these commands. So success, then I can ping. So I ping 10.0.0.254. So for my PC, I will ping 10.0.0.254. Okay, the ping will be success. So yes, success. Again, try to ping. Okay, it is display PPPoE session on the server side. I'll try to display the PPPoE sessions. So I can see this MAC address. Who is this? 8888 or the client, this one. Display interface G000. So this interface MAC address is 20DF. 20DF server. So 20DF. This session ID with this 20DF is match the PPPoE client address. Okay. Let's look at the packets. So you can see it start with a PADI. PADI, then PADO, PADR, PADS. Success does establish a PPPoE session, and then go to the PPP negotiation, PPP establishment. Still LCP until here, and then continue with check, and then IPCP until here, and then success. Then you can start to send data. Send this ping request, ping reply, and then continue until, because there I put on demand. Here I put on demand. So when some tests the PPPoE session will only establish when the PC want to send, okay, when to send the data to the internet, to the outside. So usually we don't put on demand. Okay, if you don't put on demand, means permanent up. This is what in your home is what used in your home for your home router is permanently up. So these are the demo I want to show to you. So let's try to also look at how the packets looks like. So this is the, let's say, request. Here, Ethernet 2, yes, PPP over Ethernet. So at Ethernet 2, I have a PPPoE header, version 1, type 1, code 1, session ID, payloads. This is the PPPoE session header, 8864. Remember this, 8864. Then PPPoE IPv4. Okay. So that's all. So yeah, this is the PPPoE frame. Okay. Okay. So that's all for the PPPoE for WAN technology. Okay, now we are going to another one. Let's see. What's we're going to this net. So for this, I also share to the WhatsApp group. Okay, I will share to the WhatsApp group. So let's take a break before we go into this. So let's take a 10 minutes break. So you go to refresh yourself again. So before we go into this topic, network address translation. And 23. Okay. So this one, and I start the device first. Okay, so let's continue. So network address translations is another WAN technology. So why do we have this? As I already told you in the last topic, we need because inside here we are using private IP. So when we're going to go to public IP, we need to translate our private IP into the public IP. So again, why do we need to separate into private IP and public IP? So this because because we don't have enough IPv4 address for everyone. So even though we separate into private IP and public IP, and we use the method of this method, network address translations, because so that we can reduce, or can slow down the depletion of IPv4 address. But again, the IPv4 address is finished, almost finished, or assigned to everyone, assign everything already. So actually, this net is you can say this is a method, a temporary measure for us to in migrating from IPv4 into IPv6. So in IPv4, we have this network address translation, but we go into IPv6 no more, because in IPv6 we don't have private or public. No. So in IPv6, all your devices will have a public IP. We don't call it a public IP in the IPv6. Again, in Wednesday, I will tell you what is IPv6. So, and then we continue to this. So net is a measure taken against rapid depletion of IPv4 addresses. Gateway, or your home router or router, the Apple operates as a private or public address boundary, because the router will be the one who translates your address. So in net, so this is private, the right side is the public. In the net will see the private as the inside, public as the global, because inside and global, these are the commands we'll use in the keyword will be used in the commands. So translation of address is performed between boundaries, between inside and global. So inside, you are using private IP, global using public IP. So how there are 5 types of nets. NAT, we just call it NAT, static NAT, dynamic NAT, network address port translation, or we call it NAPT, and then easy IP, and the last one, NAT internal server. Okay, so there are 5 types. What are the difference between these 5 types? The major difference is the first one, static, dynamic, NAPT or easy IP, is the traffic is initiated from private to the public, private to public. Either the public will reply. But the last one, the net internal server, is the traffic is initiated from the public. Okay. So let's see. Later we'll see one by one for these 5 types. So first one, static net. Static is one-to-one mapping of private to public address. this limits the need for address management with session flows. So this traffic is inside the router. You configure. This private IP is bind to this public IP. Only this private IP can be translated to this public IP. Okay. So when this host A with private IP 192.168.1.1, destination 111 will send to the internet. So when this packet come to the router check, oh, 192.168.1.1. According to the configuration, this should be translate to 200.10.10.5 and then forward. Destination remain the same. So when the receiving side reply. So the router is received. Okay, I see this. Okay, destination 200.10.10.5. Okay, according to the configuration, this should be translated back to this. And then I see this. Oh, this is 192.168.1.1. This is host A. So forward to host A. So, but how about this one, host B? If this host B also wish to go to the internet, you must have another public IP. So this method doesn't really help to slow down the depletion of IP address. Actually, this one-to-one. Okay, but we use this mostly. You can use this for make the server. We don't use this for normal end client. We use this for server. Okay, it's better. So it's one-to-one mapping. Okay, so how about dynamic net? Dynamic. If for dynamic net, we have to create a pool. This is just like your DHCP. You have the pool of private IP in DHCP, and here you have the pool of public IP. Okay, and then it's the same. So everyone in the host, your host, can take turns to use maybe they can take turn to use the same public IP to access the internet. So same like your DHCP, end devices, your DHCP client might reuse the same public private IP in different period, different time. Okay. So here, so you have to configure a public IP pool, and then okay, let's say host A wish to access the internet. 192.168.1.1 is a private IP. Okay, router receive, then router will check. Okay, going to the public. So do I have any public IP? Yes, I have one available. So I take this translate for host A. 192.168.1.1 translate to 200.10.10.11 and then send to the destination. And then I record down in my record. I must record this 192.168.1.1. I translated to 200.10.10.11. So this is used. Okay, and then another host want to access the internet. So this private IP is 192.168.1.2. So router check. Okay, I accept another one. So I translate to this. Okay, this to this. So 200.10.10.12 send to destination. So I record 192.168.1.2. I translated to 200.10.10.12. Okay, then no more. Okay, if the host C coming, another PC coming. So take turn, have to wait. So this one, when the public send a reply. So send a reply, the router will look at the destination IP address, or if I see 200.10.10.11, translate back to 192.168.1.1 and send forward to host A. Same. If the router receive destination IP address 200.10.10.12. Translate it back to 192.168.1.2 and then forward to host B. And then this public IP put back into the pool and can be reused by host C. So private address mapping based on the address resource pool. This allows user to utilize public address based on needs. But according, if you want, depending on how many users, how many hosts you want to access to the internet simultaneously. Let's say if you want 100 PC, 100 users to access the internet simultaneously at the same time. So you must have 100 public IP in the pool. Okay, in the pool. So this not really still not the best way, not the good way to decrease the usage of public IP. So we can further enhance, further improve. So we improve. We use network address port translations. So here we still have public IP group. Yes, still have the group. But let's see. Host A 192.168.1.1. Host A 1.1. So router receive this. Router check the pool. Okay, I have public IP 200.10.10.11. So I translate to this. Translate this private IP to this public IP 200.10.10.11. But do you notice this? The port number 1025. This is from the originally from the host. Port number 1025 is also translated to 2843. So this is record down 192.168.1.1. Port number 1025 is translated to 200.10.10.11. Port number 2843, and then send to destination. Same. Another one. Host B want to access. Host B send out this. So private IP 192.168.1.2. Port number 1028. Again, router can check the pool. Okay, I can use back the same public IP. Translate to 200.10.10.11. Exactly the same. But the port number 1028 translated to 2843 different. So this is record down here. Record down and send to destination. So when the reply is coming back, reply coming back. So routers saw the destination. Destination IP address 200.10.10.11. Destination port number 2843. Okay. Translate to back to this 192.168.1.1. Destination port number 1025. Forward to host A. When this reply, send back. The router check. Oh, destination IP address 200.10.10.11. Destination port number 2843. Translate back to 192.168.1.2, port number 1028, then forward to B. So port numbers distinguish mapping of the same public IP address. Okay, I can use the same public IP, but I use the different port number. This means that I can reuse the same public IP again and again. Okay, so how many public IP you need for this? You need at least one public IP in the pool and another one public IP for your router. Total, you need at least 2 public IPs. Okay. For the previous one, dynamic, static net, they even need more. Dynamic, how many pool in the public IP in the pool and at least one here for your router. Here static net also the same. You must have a public IP for your router. So this we need at least 2. So we can further improve this one. We don't have pool anymore. No pool address. No pool. So
sorry, Mr. Bay.
Yes.
So what's the maximum number of ports we can have on a public IP?
Maximum port numbers. 65535.
Okay.
Yeah, based on the port number. The port number is really what I mean in the TCP layer. Okay, the TCP header. The port number. Okay. 2 power 16.
Yeah, but the last time we checked, some are private, some are reserved, some are registered, all sorts of things.
Yeah, they also need to be considered. So mostly it's used sent from private, so we have to use back the private ports.
Okay.
Okay. So 1025.2843 same. Okay, same for host A 192.168.1.1. Port number 1025 translate to 200.10.10.1. Port number 2843 different. Same for host B 192.168.1.2 1028. Oh, translate to 200.10.10.1. Same public IP, different port number 2844. But whose public IP is this? It's the router. Router's public IP. That's why you don't see any pool anymore. No pool. Because we use the public IP of the router itself. So right here, also need to record down this public IP. Translate to this public IP and the port number. This private IP and port number translate to this public IP and port number. Same method. When the reply coming back, translate back to the private, send to the host. And reply coming back, translate back to the private, send to the host. So the web interface address is used as the single public address for all internal users with port number to distinguish sessions. So this is the method. So all these 4 types, the similarity is the traffic is initiated from the private, sent to the public. Then the public will send the reply. Okay. But for this internal server, okay, before this, because we have requests from inside, and we will reply from outside. How the outside reply based on the source address, source IP address. But what if we, let's say we have a server at the private? So how can the outside access? If we have to wait a server to send the request, doesn't make sense. The server is waiting for requests, means that we had the request sending from outside, and then server reply. So external source can reach. This is for external source to reach the internal address. Mapping of both the IP address and port number is performed. So when there's a hosting, the web hosting or the service provider, this is very familiar. They will be very familiar with this. So on the internet, on the hosting at the outside, on the private at the outside, or you can mean the user from another private network. They send their request translated to private public IP, and then the destination IP is the public IP. So to 200.10.10.5. Port number 80. So this packet, this destination, come to the router. Router check, 200.10.10.5 port number 80. According to the configuration, translate to 192.168.1.1 port number 8080 and forward to server. So this is then the server reply. Okay. So these are the 5 types of net. So these are the configurations. So let's look at the first one, static net. So you should go into the ENSP. So in this topology, let's see what I have. Oops. So in here, I have my private network, public network. And then PC1, the private network is 10.1, 10.0.0. This .1.2.254 is the gateway. This is just a dumb switch, layer 2 switch. Okay. And then my public network, I have 200.0.0.254 and .1. This is represent the internet. This represent my net. This router is my gateway. Okay. So then these are the configuration for my net, sysname net, and then configure the IP address for the private network interface and IP address for public network 200.0.0.254. And for this R1, which represent the internet, use the same name R1, IP address one of the public IP, and then IP route static. Route static, this is the default route. Whatever received, I just send to this next hop, because R1 supports should not recognize the network 10. Should not know how in the router one shouldn't have network 10.0.0 inside his routing table. So he must use the default route to send. So if you look at the first one, static net. Next, okay, this is do at the outbound interface. G1. Net static global. And static is a command. So global IP address 200.0.0.10. Inside means a private IP 10.0.0.1. Means PC1. We will use translate PC1 private IP to this public IP. So let's configure this first, the name and the IP address. System view, system for this. Copy. System view, system. Okay. So I try PC1, I try to ping my gateway 10.0.0.254, ping 10.0.0.254, yes, success. So can I ping 200s, ping 200.0.0.254, no, .1. Yes, can ping, because the router knows how to go to 200.0.0.1. But let's see, capture 0. Capture G1. I capture both sides because I want to see the this should be not SCP. The left side is inside the private. The right side is the public. So again, PC1, I ping the R1 again. So sent by R1, you can see 10.0.0.1, 200.0.0.1. This is private IP, sent for private IP, and then forward by the gateway, the router, my gateway. So without translation, 10.0.0.1, 200.0.0.1. Okay, this is what we have without translation. Okay, but now we want to do translations. So we want to do static net. go to N1, add this interface. So in this command, enter. Okay, so I can use display net static to check. So I configure a static net. This private IP inside, this is a global IP. So again, so I try again, ping. I still can get the ping, but let's see what is the difference. Oh, no. Okay, you can see this private IP 110.0.0.1 is translated to 200.0.0.1. Okay, so when the reply coming back also .1, okay, then translate back to 10.0.0.1. This one 10.0.0.1, the destination. Okay, this is a destination. Yes. Okay. So after this, I want to undo this. Just going to do another one. Okay, undo. Okay, let's check. Okay, no more. So this time, take ping again. Okay, no more. No more translation. Okay, let's try the next one. Dynamic nets. So for dynamic net, you have to create a address pool. So net address group 1. You can group 1, 2, 3, 4. And then what is the range? 200.0.0.21 until 200.0.0.30. So I have 10 public IP. So I create a pool first. We do it one by one. Now create a pool. Okay, the pool is created. And then what are the IP address can be translated using this pool? So I use the ACL to identify my interested traffic based on the source IP address. So I use ACL, the basic ACL 2000, rule permit. Okay, rule permit, source IP, source 10.0.0.0, and then behind is a wildcard. Okay, but this wildcard also means 0 means must match. 0, 0, 0 means must match 10.0.0. The behind all are 1. If you convert to binary, it's 1, 1, 1, 1. Means the last 8 bits can be either 0 or 1. Means doesn't care. It can be 0, it can be 255. Okay, as long as the front 3 number is 10.0.0 is matched. All this IP address can be translated to this public IP. And these two things that I created this ACL first. Do it one by one. Okay, I create the ACL, and then these two address group and ACL I put into the my public interface G1 net outbound 2000 address group 1. Net outbound means you translate all the traffic that going outbound this direction. Means if you are standing on this G1, this is the outbound. This is inbound. If you are standing on G0, this is the, let's say, this is the inbound. This is the outbound. So depend which interface you are sending. But the traffic of this inbound and this outbound is the same direction. This outbound and this inbound, same direction. So for this, I use outbound, okay, because it is much more easier to recognize. If not, you're very confused. This one, I'm sure that okay, I'm going out. Okay, the directions. So this traffic going out, I identify the IP address using the SCR 2000 and these are the public IP, and use no port address translation, no paths. Means this is a dynamic net. If you don't put this, means this is a network. This is an APT. Okay. Now is no path, which means dynamic net. Means that no port address, no have the port. Just use the purely use the IP address in the pool. So let's it is command D net paste. Okay. So I can display net outbound. Display net outbound. I can see at interface G1, I have ACL 2000 address group. This is address group 1 and no path. Either path or no path. So ping again. So this time I should see IP address 200.0.0.21 until 30 in the range of this. In this range. So again, try again. What's happened? Let me check. So the is sending out. Right? PC1. Yes, I get the reply. Okay. So I get from here. So what I can see is for each IP address, for each ICMP request I send out from PC1, it will translate to one using part one public IP. Second one, this is .21. Second one, .22. Third one, .23. Next one, 24, 25, 26, 27, 28, 29, 30. It's used up, use everything. Okay, use up all the public IP in the pool. Okay, so this is the disadvantages of using a dynamic net. Let's see. Let's see. I undo this. Let me undo this. Undo, paste. So do another one. Okay, let me do this, but with like this. So without no path, mean this is a display net outbound. This is path with port address translation. So let me try again. So I still can ping. This time, see the difference. It's the same, but here I only use the where is it? The 29. No. $29. Okay, 1, 2, 3, 4, 5. This is the request, echo request. Okay, so 1, 2, 3, 4, 5. Okay, so this is the first one. Send my PC1, send out, translated to .27. Second one also .27, .27, .27, .27. But what the different change here is because we don't have port number for ICMP because we don't have TCP ports. Here, what is being changed is the identifier somewhere here, this one and this one. Identifier is changed. So we can use back the same. Same. But let's see. Go to this one. Let's see. We use our server to try to ping. If you use server, try to ping 200.0.0.1. Let's say 5 times ping also. Send So I'll see 10.2. This time I use 23, 23, 23, 23, 23. So it means one public IP can be reused. Huh? Okay. So this is NAT with NAT, PAT, port address translation. So let me undo this first. No more. And we have to ping again. Yes, can ping. So no more translation. So look at the next one. Easy IP. Easy IP. You see, there's no address group need to be created, but you still have to identify which source IP you want to translate. 10.0.0.0.0. Same ACL 2000. So I don't create this again. But in the interface G1, the command is a very short one. Just net outbound 2000. There's no address group 1, no pack. Just net outbound 2000. Okay. Net outbound 2000. Okay. Display net outbound. Okay. I have G1 ACL 2000. Use the IP address or use the interface. 20, the 200.0.0.254, easy IP. Okay, so it will be the IP address of this interface. Okay, let's try. PC1, ping. Server 1 also ping. Okay, see, it's from 1. Okay, .254. 254. Okay, either from PC1 or server 1, or translated to 254. 254. Okay. Let's see this one, PC. Okay. So this is easy IP. Okay. So easy IP is okay. So last one is the net server. So in net server here, let's see. We also configure at the G1 net server. So let's dissect the command. Okay, net server. Net server protocol. You want TCP or UDP? Global. What's the global IP address? Let's use the current interface. This interface means the G1 IP address. Because if you are using this, it's better because your public IP provided by your ISP will maybe it will update, it will change. If you are using dynamic public IP, it will change. But if you use this current interface, means that every time the server want to go up, the reply want to go up or coming in, you will know or using this current public IP. So it will be better if you use current interface. And then what are the port number? If you see the public IP is FTP, this current IP, and see this port number FTP. So the inside will be this private IP and FTP also. This is the standard command. Okay. So how about I configure one by one? Next, let's see. I go to G1 net server. Question mark. Net server protocol. Okay, protocol. Question mark. I can have ICIP, TCP, UDP. So how about I choose the TCP? Okay, I can use 6 or I can just use TCP also can. So next, global question mark. So I can specify an IP address or I can use a current interface. Okay, current interface, question mark. Okay, what are the port number you want? Okay, so many here. So I choose FTP. Let me use FTP. FTP. So question mark again, inside. Question mark. Okay, what is the IP address of the private IP? So 10.0.0.2. Question mark again. You can use FTP or either the port or the number. FTP is 21 for control. So FTP, enter. Yes. So display this. What do we have? This is the command. Okay, exactly the same what we have typed. Okay, so it's done. Again, let's check. Display net server. Let's check the status. So I have a global IP, current interface 21. The real IP or currently IP is 200.0.0.254, and the inside port is 10.0.0.2, 21. Okay, so let me do some server. Let's meet server info. I haven't shown you this and how to use the server info. Server info, you choose the FTP server, and then root path. You click on this is to browse your local, your PC, your laptop local, your Windows local folder, and then I choose my desktop. Choose my desktop. I press OK. So these are all the files inside my desktop. This is just to simulate a FTP server. Then I click Start. Then I close. So R1, I use R1 as the FTP client. FTP. So what are the IP address? 200.0.0.254. Enter. Can it be done? Yes. Username, no username, just enter. No password, just enter. Now I'm inside the FTP now, so I can use dir. Yes. Check. These are all the files on my desktop. So I go to Wireshark. So in my Wireshark, I can see coming from 211. For FTP, let's look for FTP. So TCP port number. This one. So destination port number. Let's see. 21. Coming in FTP. So translated to destination 21. Port number source 64963. 64963 the same. Okay. So translate. Okay. These are the TCP traffic. 64963. Okay. So can you change? Let me do something. I stop here. If I change this to, let's say 100. Put a bigger number. 10,000. Start. So here I need to change this. FTP. Let's change to 10,000. At the front here, I still need to change to 10,000. Can I do so? Is then the private inside. Usually the inside is FTP, doesn't matter. Cover, yes. Display this. Okay, so outside I should use 10,000. Inside stay as FTP. Let me just stay this the same. Don't change that. 21 start. Okay, for R1 this time I quit. Oops. Version close. I had to wait for a while. Okay, FTP 200.0.0.1 is .254 space 10,000 user. Okay, dir. Yes, it can be done. Okay, so I can access to the FTP using different port number for the public. Okay, so again, display net server. Let's see. Display net server. Current interface port number 10,000. Inside IP 21. So these are the examples I can demo to you. So these are the configurations. You can go back and check again. So which form of translation will allow a server in a DMZ to be accessed from both an external and an internal network? Which form? So always, when the server want to provide a service, we'll always use a net server. Okay. So the user from the public can access using a public IP, but the user from the private network still can access using private IP. What is the function of the PAT, port address translation feature? Is okay. So the translation will perform on the IP address and also the port numbers. Okay. So that's all for the net. Okay. So we can stop it here for today. So let's see. So today, what we have go through for today. So today we got the first topic is link aggregations. How you bind two links together to get more bandwidth, more reliability, and load balancing, less congestion. And then we go to VLAN principle and the VLAN routing. Okay. And then we go to WAN technology, HDLC, PPP, and PPPoE. And then the last one for today, network address translation. Okay, so do you have any questions regarding all the topics we're going through today? So any questions? You can either post in the WhatsApp group or can open your mic and ask and speak. Okay, if you don't have any questions, I think we can start here. So all this topology I shared to you today, you can open and you try to do it again. And then if can, you can also try to modify something. Maybe modify the VLAN number, the VLAN ID, or the IP addresses. You can try to do it. So to get yourself familiar with the command. Okay. Especially the I haven't shown you the for hybrid port. Maybe you can try it on your own, or use yes, you should try it on your own. Okay. You can try to change the trunk port to a hybrid type port, or the access port to a hybrid untapped port. So if you have any questions regarding how to if you fail, if you cannot do it, maybe tomorrow we can discuss again. Okay, I can check which part of the configuration you might do the mistake, or which one. And then yeah, so that's all for today.
Mr. Ben, thank you.
Yes,
All right,
thank you.
Mr. Bay.
Thank you. Thank you for your time.
There's so much to digest anyway. But
yeah, sure.
Have a nice time.
Yeah, have a nice day.